Excuse me.
Hello, Alan. How are you?
I'm not too bad, Rob. Thank you. Yourself?
Oh, pretty good. I've got a day off today. I'm not at work today, so any day you're not working is good. I haven't quite joined the retirement lot yet, but a few more years to go.
Yeah, I'm in the other position where I actually wish I could be at work, but health prevents it.
Well, that's not too good, Alan.
No, that sucks, but such is life.
It is, unfortunately.
And of course, it's starting to get cold up here now as well.
Yeah, we're starting to get warmer. It's not been the greatest spring really here. It's we've had days, it's got to 25, and then the next day it's like 15. It's just been ricocheting from one to the other.
Yeah, you'll have to forgive me, Rob, but I can't remember whether it's Australia or New Zealand you're in.
New Zealand.
So what time is it there now, Rob?
It's 9:02 because we're on daylight saving time.
Oh, it's 9:02 in the morning?
Yes, AM.
Because New Zealand is very, very, very far.
Yes,
correct.
Yeah.
13 hours.
Correct, because we're on daylight saving time.
I see.
Yeah, we're very close to 180 degrees out of Greenwich. We're slightly west of that, but not by much.
On a flat Earth?
No. On the round thing that we all know it is.
Yeah. I know personally my antipode would drop me somewhere in the Southern Ocean, about 1,300 miles off the south end of the South Island.
Yeah, that'd be about right.
Well, good afternoon, everybody. We are live. How you guys doing?
Good, thanks, Blue.
Yeah.
Good to
Very
see you,
good,
Rob.
thank you.
Alan. Bebby's here. Let's see. I need to, get the screen up out there. Got 42 people watching. A whole bunch of people out in the chat. I see PhD Tony out there, Mark 10. Quinlan 1977, Stringer News. Mobius. And Clive Wells. Quite a few already. Glad you guys could make it. We're going to give you just a couple of minutes, I think, before we get off into celestial navigation. Maybe spend just a second talking about reciprocal zenith angles. This seems to have caused a real large amount of turmoil in the flat Earth community because they don't have an answer for it.
Well, they don't have an answer to anything.
Oh, yeah, I guess there's nothing new when it comes to that. But I really don't know how much more simple this could be. If you take two theodolites separated by a distance and you aim those two theodolites at each other, you can read the zenith angles from each of the two theodolites. And when you add those two together, in every case, it comes up more than 180 degrees. What does that tell us? Clearly, those verticals are not parallel with each other. This is straight out of Euclid, Book 1, Proposition 29. If those verticals are parallel, the internal angles, A and B, that I'm showing on the screen, absolutely have to add up to the sum of two right angles. There's no way around it. I'm not sure you guys in the chat are seeing it. You may have to watch it on YouTube, but I've got a slide from the little presentation I did with Bev last week. And Bev seems incapable, as does Mobius and the rest of that crowd, of understanding that Bev has created a textbook begging the question fallacy. He says level is equal altitudes. Okay, I'll go along with that. That actually is the definition of what level is. But then he turns around and says horizontal is also equal altitudes or equal elevations. Well, maybe it is, maybe it isn't. And that's the begging the question fallacy, because then he turns around and says, then level is horizontal. No, you haven't shown that. Your conclusion was created by you and your constituent parts. What am I missing here? Tell me, Bebby. Oops. Where'd he go?
Right. I'm not missing anything.
Aha. I don't think so either. Very simple, very straightforward. This test doesn't lie. It doesn't depend on anything other than two properly adjusted theodolites looking at each other. That's all. So anyway, I thought I would just take a moment and talk about that. I can stop talking about that. Let me turn this thing off. Oop. Anyway. Yeah, I see Mobius in the chat saying, imagine having two unrelated angles. What do you mean unrelated, Mobius? What the hell are you talking about? Unrelated angles. Not even worth arguing about, I suppose. Well, I'll tell you what, we already got 60 people. I think maybe what we ought to do is turn this over to Bebby and let him do what he's going to do and tell us some things about celestial navigation. So anytime you're ready, Bebby, go ahead and...
I'm ready. Can you hear me okay?
Yeah.
You can hear me? Can you see the screen? Should be full screen now.
Hold on. Let me get it up and we'll see. Yep.
You've got it.
Looks good. Everybody.
Okay, thank you.
Yep, go ahead.
Thank you, Blue. Thank you. So I've got about 30 slides on celestial navigation and should get through it. So, some of them are fairly small slides, so should get through it in 30 to 35 minutes, after which we can talk about it. Does celestial navigation work? Spoiler, yes, it does. So if you're satisfied with that, go now. But please don't go. There's some other stuff there. Someone asked me, I'm on a celestial navigation forum, and someone said, why the hell are you doing this, Bebby? They know what it's about. It's about globe denial. And they said, if you argue with an idiot, then there are two idiots. You're an idiot as well. I'm going to try and tackle that in the last slide. There are reasons we should be interested in this, and I'll cover that later. So let's go. So always start with the history, start with the definition. Celestial navigation, we use observations of the sky to determine our position on Earth. It's a very old subject. The Polynesians apparently used it to cross the Pacific or to colonize the Pacific Islands, perhaps as early as 3000 BC. However, I'm not going to be talking about that because I'm going to be talking about the kind of celestial navigation that specifies our location using latitude and longitude. Apparently, Hipparchus, a Greek astronomer, 190 BC, was the first to do it that way, and what he put in place survived the test of time. So latitude is degrees north or south. Longitude is degrees east or west. How do we find that? I'm going to be talking about the noon sight. A lot of people in our forum, Blues forum, will talk about star sights. They're astronomers. I'm not going to be talking about those because they are harder to do. Because you can only see star. You need a horizon to do a star sight. You can only see a star about an hour after twilight. After that, you can see the stars very well, but you can't see the horizon. Plus, the mathematics of star sights is hard to do and very hard for some people to understand. So I'm going to keep it absolute simplicity here. So how it works, from the altitude of the sun at local noon, a local noon is the time, or the point of the sun's traverse across the sky when it is visibly highest in the sky. From its altitude at local noon, we can determine our latitude, i.e. degrees north or south. There's a subtlety there called declination, but I will discuss that later. From the time of the local noon, so you find out that you watch until the sun is at its highest, clock that time, make sure it's Greenwich Mean Time and not local time. From that time, we can tell our longitude, i.e. degrees east or west. We do that. There's an objection to this, which I'll cover later, but just saying now, if you assume the sun moves at around, if sun moves around at 15 degrees per hour, note I'm not assuming that the Earth moves here. I'm just going on the observation, which we all know, that the sun moves around the sky, it rises in the east, sets in the west, and it moves at 15 degrees an hour. Then we use the speed times time formula to work out from the difference in local noons between Greenwich and now, multiplied by 15, and then you get degrees longitude. And for this, obviously, you need to get the time right. Accurate timekeeping is essential, which people did not have. People did not have before John Harrison, who designed the famous chronometer in the late 18th century that was accurate enough to get really, really accurate readings of longitude. People could do it before that, but it was inaccurate, and there were accidents that occurred because of that. Data required, obviously the altitude of the sun at local noon, for which you use a sextant. Greenwich time and date of local noon, for which you need an accurate timepiece and clock. The time of Greenwich noon, this may be confusing. Greenwich time and date of local noon where you are. So I suppose you're in the Pacific somewhere. You want the local noon in the Pacific, but you want the Greenwich time for that. But you also want to find out the time of noon in Greenwich itself. Now today, 8th of December, in Greenwich, the sun was at its highest at 11:52, not 12 o'clock exactly. And that time changes throughout the year. So since you want to find the difference between the time of local noon where you are and local noon at Greenwich in hours, you have to know the actual time of Greenwich noon. You need to know the declination, as it's called, of the sun at local noon, for which you use tables. We'll talk about that later. You need to know the sun's semi-diameter, which I'll talk about, the height of your observation, and refraction. I will talk about all these because there are objections coming from globe deniers who say that oh well, you've got what they call the magic book or the magic numbers. You know, do these numbers not presuppose that the Earth is a globe? And I'll be saying, well, no, it doesn't, or it helps if they do. So that's what we're talking about. I'm now going to go through 6 or 7 objections from the globe denial community that says CellNav can't possibly work. So first objection, and these are all the ones I put in quotes are actual objections. People have actually said this, and I've simply copied and pasted what they've said accurately. First objection is you need to know your position before you can use celestial navigation. So go ahead and try and prove it from an unknown location as opposed to backing into it from a known location. I'd pay money to watch a live camera viewer drift in the South Pacific with a protractor and a Timex. Okay. Someone else says, not that guy, you're not actually trying to find your position, you are just measuring an angle. Okay. And my favorite one is you should already know where you are. So you're the navigator and the captain says, okay, navigator, where are we? And you reply, we're in a boat, sir. So difference between dead reckoning and observed position. So a navigator can estimate a vessel's position, emphasis on estimate, by carefully keeping track of speed and course. So course you get from the compass. Speed you get by sort of estimating the speed of the boat, which in the old days of sailing ships, they're used by knots. They'd actually throw a rope with knots in it over the side. And that process is known as dead reckoning. The problem with that is that over time errors accumulate and you have to correct the dead reckoning position using celestial navigation to obtain a fix. And that corrected position is called an observed position. So an example of that, famously Frank Worsley navigated a small lifeboat from Elephant Island in to South Georgia in the South Atlantic, Antarctic, to get a rescue for the other 22 men of the Shackleton expedition. Excuse me. The 800 nautical mile journey remains one of history's most remarkable feats of seamanship, which it was. So you can see that's the lifeboat, which the carpenter changed into a sort of boat that could get through the seas of the South Atlantic. And it's just amazing to think that those guys, 4 of them, managed to get all the way from Elephant Island, which is practically in the Antarctic, all the way to South Georgia. Note, when they got to Elephant Island, they'd had a long struggle across the Weddell Sea. They didn't actually know where they were when they found Elephant Island. Worsley, the navigator and captain, had to find that. So if you look at this chart, you'll see the different positions. An empty circle, a white circle, indicates dead reckoning. A black circle is the observed position obtained from celestial navigation. And you will see at Elephant Island, there's a black circle. That's because they didn't know where they were. They had to have quite a complex, and also the clock that Worsley used was not correct. So they had to work out from the position of other places that they knew nearby what the correct time was, or an adjustment for that time. And they had to use celestial navigation itself to get the position of Elephant Island. Then, through quite an arduous, really an almost impossible process, they managed to get from Elephant Island to South Georgia, 25th of April to 8th of May, including one really horrific storm in which the boat nearly sank. But they successfully arrived at South Georgia, went to the whaling station and managed to rescue the other 22 guys who were stranded on Elephant Island. Just an amazing piece of work. And there, just for those who believe this might have been made up, there is Worsley's log. We've got his entire log. People have worked through and sort of annotated that and worked out how he actually did it. And for those who want to watch it, there's a great film, an hour and a half on YouTube. I'll put that link up on the YouTube video when it comes out tomorrow. So in summary, first objection, celestial navigation, you need to know where you are. Well, no, you don't. You absolutely don't. And Worsley's expedition proved that. They did not know where they started from, and they had to find out whether they were at the right place when they got to South Georgia. Objection 2, horizon dip correction presumes the Earth is a globe. Okay, well, let's look what we're doing when we use a sextant for a noon sight. They're simultaneously changing the index drum on the sextant, which changes the observed angle, and twiddling around with the sextant so that the sun, the lower limb of the sun, exactly touches the observed horizon. So that blue thing there is the visible horizon. And the problem with the visible horizon, as you can see from this slide, is that your level, which you should be measuring the sun's altitude from, is not the same as the observed horizon when you're any height above the water. In fact, when you're any height at all, in fact. So as you can see from there, you've got the horizon, then you've got a very crudely constructed but workable water level, showing you that what is level, your level is higher than the horizon. So what you're measuring when you look at the actual horizon is you're going to get an angle which is a little bit larger, in this case quite a lot larger than the angle you should be using. You should be sighting that water level and the sun in order to get the correct altitude to horizontal. At what you're actually getting with the sextant is the horizon itself. So you need to deduct that angle. So you have to work out what is called horizon dip. And for that, you need to know the height of the observer from sea level. Normally not very far if you're in a boat. You need to know the algorithm that corrects the dip, and there is the algorithm there. And capital H is your height, which you have observed, and the R is one of your magic numbers. Someone's bound to object. Well, hang on, you've got this correction, you've got this R, and isn't R in fact the radius of the Earth? Yeah, okay, it is. That number happens to be the radius of the Earth, but why does that matter? We know that horizon dip occurs. We know, let's go back, we know there's a difference between level and the horizon, between true horizontal and horizon horizontal. There is a difference. That's absurd. That's a fact. And we have found out by experiment that formula there, the square root formula, actually works. So you may want to use that formula to justify the fact that the Earth is a globe, but that doesn't have to be. You could still be a flat earther and say, well, that is the number that we made to work. And that's how we found out how to correct for horizon dip. It must mean something else than the radius of the Earth, and you could perfectly validly say that. So takes care of objection 2. Objection 3, clock measures time, not distance. And that's correct, yeah. That objection, as literally taken, is correct. A clock does measure time, not distance, but there's a hidden premise in that objection, namely that longitude is somehow time. No, it's not. Longitude's measured in angles, in an angle. But if we know the time an object has moved at a certain speed, we multiply time by speed to get distance. So if you drive at 60 miles an hour for an hour, you have driven 60 miles. You multiply 1 hour by 60. That's kind of obvious. And by the same token, you multiply the speed of the sun, 15 degrees per hour, times the number of hours. So if the difference between Greenwich noon and local noon is 2 hours 40 minutes, which is 2 2/3 hours, multiply 2 2/3 times 15 to get 40. So you know, if that's the case, you are at longitude 40 west. So a clock does measure time, but time times distance, time times speed is distance. Objection 4, another real objection. Someone objected, I couldn't verify this, so I need to provide verified locations for all your observations and the method by which you verify them. Okay, I'll take something from my Antarctica trip earlier this year in January, February. I kind of knew the Earth was round before I went, but I just wanted to check because we should take nothing for granted. So the method I used was to first of all, they would say, "Oh, we've arrived here. We've arrived at Half Moon Island." So I'd first check Google Maps to see something that looks like Half Moon Island. I'd find the Google Map GPS. I'd check that against the ship's GPS, and third, the suitable weather conditions, I would also take a sextant reading to check against both. That's a three-way check. And this illustrates it. You can see there where that red balloon is. You can see what is obviously Half Moon Island. You can see why it's called Half Moon Island. That was on the 1st of February 2022. The ship's GPS said 62:35 south, 59:53 west. And that is, in fact, pretty much where we are. The sextant readings were all a little bit out. I've got good enough to navigate within 1 or 2 nautical miles. Better people can do it better, but I never found a situation there was any substantial disagreement between ship's GPS, Google GPS, and the sextant that long. A more subtle one, knowledge of declination presupposes a globe model. Yeah, you have to adjust the sun's altitude, the observed altitude at local noon, by a number you get from a table called declination, which you add or subtract in order to get the true latitude. And it might be objected that sort of you're presupposing the globe if you're doing that. Well, no, because declination is something you can observe. Here's a garden, a picture of a garden at the bottom, which might be my garden, can't say. Sad thing about this garden is that as you get towards August, September, the shadow you can see there, which is the shadow of the house, completely obliterates the garden, and there's no more. My wife can't sunbathe anymore. Conversely, you said June the 21st, that shadow is at its shortest. The whole garden is in sun. Everyone knows this. Everyone can observe this. Who has a garden and sort of likes to sunbathe. Everyone knows that shadows move up and down as you move through the year. It's an observable phenomenon, and it just so happens that the formula I've given there, the one that says d equals minus 23.45, that actually works. I can actually predict the length of the shadow in that garden using that formula. It works absolutely spot on all the time, year in, year out. An observant person may object, yeah, but isn't that 23.45 the angle of inclination of the Earth? So you're a glober, right? You know, that's an objection. That formula is obviously a globe formula. Well, so what if it is? You can be a flat earther, and you might have found out that formula worked perfectly well. So what's the problem? The phenomenon exists, and we have to explain it. And that formula explains it perfectly well. If you feel that sort of compels you to accept the hypothesis of a globe Earth, then so much the worse for you. And my favorite objection, both from the same guy, celestial navigation is based on circularising. So I looked at lights in the sky and matched it with my map that's based on lights in the sky. Globe deniers don't call the sun, or moon the moon, or the stars the stars. They call them, for some reason, they call them lights in the sky. I don't know why. And you cannot confirm your lat-long coordinates, which are based on celestial observations, by using celestial observations. Right. Okay, that is actually true. That's absolutely true. And let's look at Emmanuel Bowen's atlas. It's one of the oldest books I've got. Actually, it's not, but it's an old book, published in 1747. It is all based on lights in the sky. So let's take a look at that map. I'm sure you all recognize what that continent is. You can see South America clearly. The entire coastline is there. You can see the western seaboard of the United States. Sorry, my mistake. Eastern seaboard. All there. Western seaboard, it sort of goes up to sort of Gulf of California and a bit higher, and then sort of stops around Los Angeles, which wasn't there at the time. And he says, I think it reads, parts undiscovered, although of course Native Americans live there. Parts undiscovered to Westerners. So if you check that, I have checked that, if you check that coastline against the coastline that's given by Google Maps or a modern printed atlas, it's pretty spot on. And if you calculate the distances there, these are all pretty much correct to within sort of a dozen kilometers or so. It's all correct. You recognize that as being America. And how so? Well, it was all done by lights in the sky, by astronomical or celestial navigation type methods. They had the faintest idea then, because none of this landmass had been surveyed, and much of it still hasn't. Brazil, the Amazon region, I don't think has been properly surveyed yet. They knew what the distances were from the outside, as it were, but from the inside at that time, in the mid-18th century, they had no idea what the distances between places were inside North or South America. It was all done from the outside. Not until the advent of geodetic surveying in the early 19th century, actually a bit earlier than that, but mostly in the early to mid 19th century, when all of North America was surveyed, they didn't know what the size of the place was from the inside, and only from the outside. So yeah, it was based on lights in the sky. That entire continent was, its measurements was measured from the outside using lights in the sky, and that's perfectly useful because if you want to go there, if you're now an 18th century mariner on a ship with a celestial navigator and you want to find, I don't know, somewhere in Brazil, you can go there and you can check your observer position when you arrive there with the position on the map, right? So that's two things. One, your observer position, one, the map position. And then you check that the place you've arrived at has the same name as the place it says on the map. That's all you need it for. What else would you need it for? Captain Cook. Now, Worsley navigated to South Georgia because he knew its coordinates. That was written down for him. He didn't have to find that out for himself. South Georgia was discovered by Cook, who obviously determined its location using CellNav, and his map is still accurate. I checked this out. If you look at this, you'll notice it's actually upside down. You notice the latitude increases south as you go upwards. If you check any number of places on that map, which are still recognizable by the topography, its coordinates were pretty exact, and there wasn't much work you had to do to that to correct it. So it all worked fine. Cook discovered South Georgia, wrote down the coordinates, put it on a map, or rather a map maker, Mr. Cattell, I think, put it on a map, and Worsley was able to use that to navigate from Elephant Island to South Georgia, saving the lives of 28 people. And I'll be rounding off now, just an example of how actually when you make maps, it's that the space was there. So if you look at this map of Antarctica in 1741, you see there's a complete empty space in the middle. Nobody knew it was there because no one had been there until early 19th century. But they knew the space was there. They knew what the space was like. And the whole process of map making was just a process of filling in the bits of the space. You see, Australia wasn't that well known in 1741. Cook did a lot of the work in determining the coastline. South America and South Africa obviously were known, but they didn't know about Antarctica. They only knew the place that it ought to be. Moving forward to the Shackleton expedition, Shackleton was with Shackleton was in charge of the expedition that Worsley led and the James Caird later, 1916. 1908 expedition by Shackleton got pretty far to the South Pole, and you can see it's like you've shone a torch on the map. You know, the bits that they could see and visited, they filled in from the outside again. So they filled all the bits in on the Ross Sea, the Ross Ice Shelf, Victoria Land, all the way up to, it was about 88 degrees. Shackleton nearly got there. And the ill-fated Scott expedition of 1911 did actually get there, but sadly they all died. And finally, Antarctica, as we know it today, or as we knew it in 1985. Excuse me. That's been pretty much surveyed from the bottom side, as you can see. You can see the Transantarctic Mountains, which is the route to the South Pole. You can see top left, the Antarctic Peninsula, which is the place I went to in January and February. Went all the way down south, as far as we can get until the ice got in the way. And as you can see, the whole lot's been filled in, but that's what it's for. Final objection, celestial navigation can't work because horizontal equals level, which is code for the Earth is not a globe, the Earth is approximately flat. And as I said, yeah, who cares? Who cares what is what? Who cares what the shape of the Earth is? Celestial navigation relies on observations that we can all agree on, i.e. horizon dip and declination. Horizon dips with height, yeah, fact. Altitude of sun at local noon varies with time of year, fact. And the formulas we use simply predict those observations. You don't have to have a theory about the shape of the Earth in order to make celestial navigation work. And finally, the point I opened with, why do any of this anyway? Because 99.99% of people believe the Earth is a globe. Only a very small number of people believe it isn't. Why bother? My feeling here is technology has advanced a lot, and possibly a lot of this conspiracy theory results precisely because technology has advanced so far. It's become a sort of priesthood. We rely more and more on automated computation. No one actually does sell nav anymore. We rely. The ship I went on to Antarctica had GPS. I don't know if any of the crew actually could work a sextant. And automation's great, but automation gives no real understanding of why the automation works. And there's a paradox here. Science, in the sense of meaning technology, or that sort of priesthood of a technologist, distances from the true meaning of science, which is knowledge. Science from scientia, Latin, which means knowledge, which was Latin version of the Greek episteme, which also meant sort of knowledge, informed knowledge, knowledge through demonstration or logic. Automation and technology sort of distances us from that. And I think it's every human's duty to understand how the world around them works. And final quote, stupidity is not an intellectual defect, but a moral one. Okay.
Well, all right, guys. Your turn. Anybody got anything? Or we can go to the chat if we wish.
There was one question I'd like to ask, and that was with the shift of local noon at Greenwich.
Yes.
With the time of year, because this is something I've not looked into. So if you wouldn't mind explaining that just a little bit, Bebby, it would save me having to go away and look it up.
I think, Anna, thanks for the question. I was wondering if anyone would answer that, because the obvious missing bit was that shift in local noon. It shifts around from about 12 minutes to midday and 12 minutes past midday. You'll need the equation. There's an equation called the equation of time, and that's quite complex. And I think you'll have to look at that, unless anyone here knows about it.
So this is related to the analema?
Yes, I think it is. Yeah.
Okay.
I'm sure somebody else here must know about this. Is Clive here? No.
He was out in the chat. I'm not sure. I haven't seen him in a while.
Okay, it's homework. I can go. I'm sure
It's definitely homework. It's there. If you look on Wikipedia, it's all there. And I sort of looked at it and said, well, no one, including me, is going to want to look at this. Yeah, a bit of homework.
Yeah, no, that's the perfect answer. I don't know. It's good enough for me when people are happy to admit it.
Yeah, there's Clive in the chat. Says the equation of time accounts for the elliptical orbit and other effects.
Okay.
Well, that's not Clive. What are these other effects? that's the same as saying we don't know, isn't it?
Well, no, that's the same as saying it's 150 characters in a live stream.
Yes, okay. I'm sure Clive will tell us later. Thank you.
When you say the elliptical orbit, I take it he's talking about the fact that we slow down and speed up as we go through our orbit around the moon or the sun.
Is that it? We don't know for sure. Know for sure. And of course, Bev and Co are going to be looking at this, and they're probably looking at it now, and they're going to say, "Ha ha ha!" They're all wrong.
Well, the area swept out in an ellipse is it for equal times is equal, right?
Yes.
So given that it's an ellipse, then we can say it must speed up. It would have to either speed up and slow down, because it sweeps out the same area in its perihelion as its aphelion.
That's right.
And would that be the cause of the sun being at local noon earlier or later than 12 o'clock?
I think that's
Would
a
the
part of
speed
it. I'm
account
not sure
for-
that's the whole thing, but I believe that's a part of it.
Hmm.
Clive says, oops. Clive says the elliptical orbit
Clive
is the
says the
main part of
elliptical
it.
orbit is the largest contribution. Okay, thank you, Clive.
I'm just happy that I remembered something from high school physics.
Okay.
That is one good part about talking to these knuckleheads. It makes you go back and remember all that crap you forgot.
Yeah, I remember us. Well, we were given, I think it was Ptolemy's observations, and we had to reconstruct the Earth's orbit. And we did Galileo's inclined plane experiments. And then
Yes.
we had air tables. We had air tables to test things like, Newtonian mechanics, I guess, angles and stuff and things like that.
I think you had a very good physics teacher in that case.
My chemistry teacher, I desperately remember this. It was like junior year in high school. The chemistry teacher handed everybody a candle and told them, "Now take it, go home, and come back with describe it in words as much as you can. Do whatever you want to the candle and just describe it. And then that's your homework for today."
And did you get an A?
I don't remember at all.
It wasn't one of those things where the memory was so horrific. It was blanked out then.
I remember for that class, I remember something about this acid is extremely dangerous and you need to wear glasses and you need to listen to me because it is really dangerous acid.
Yeah. When I was doing A levels, so the bit between 16 and 18 here in the UK, I had a chemistry teacher who used to like to say, at this point, we used to do an experiment, but we're not allowed to do it anymore. It was an experiment best done at arm's length, preferably somebody else's arm.
Yeah. Well, biology, we dissected worms, and I remember one of the students swallowed a bit of the worm.
Was it nice?
They're prepared in formaldehyde. I don't expect it was very nice, but he was one of those kinds of kids in grade school that does things on a dare, no matter what you tell him.
Yes, yeah. I've just seen Mike Dornan in the chat saying, sometimes I think, are they here? That's us. Just to convince each other of their model and lick each other's wounds. So clearly, he's not paid any attention to the presentation whatsoever. He's like many people in the chat, I have to say, particularly on the other side.
Well, I found it very helpful to me because it spurred me on to go and research things, to remember things in high school, but also to just look up things, watch YouTube videos, look up things on different websites. Since I've been in here in the flat Earth community, I've taken a course in introductory logic at University of Minnesota. I mean, it's introductory. It didn't get too far. I mean, and other things like that. I mean, so it's been helpful to me. I've enjoyed it.
Thank you.
I don't think Bebby has, because I think it's you kind of stooping kind of low, isn't it?
Is it?
It is. And I mean, the thing that gets me is that for somebody in Bev's situation in the UK, there's loads and loads of adult education stuff he could go out and do that wouldn't cost him anything.
So Bebby, you're a logician, right? I've forgotten your credentials.
Yeah, logic and philosophy.
That's great. So Bev Try Thinking talks an awful lot about dialetheism. And I don't know anything about it. It doesn't make sense to me. I don't understand a true contradiction. I can, it just doesn't make any sense to you. Do you accept Graham's dialetheism? Because not every logician I've ever talked to says, some of them say it doesn't make sense to them.
I've looked at it in the past, not recently, and this is Graham Priest we're talking about, isn't it?
Yeah, yeah.
There is a sort of logic to it. I'd say mainstream logicians really don't pay much attention to it. I certainly don't, for different reasons. I don't agree with it. That would be to go deep into the matter. The problem is that Bev sort of latched onto that. Menius a word. He takes it to mean implying a contradiction, and then he says, "Oh, well, your globe model implies a contradiction," which it absolutely doesn't. There's no way it implies a contradiction. Therefore, he says we are dialetheists, which is just bloody nonsense. But there you go. And I mean, a lot of his stuff is just sort of picking onto words he's found out from, I don't know where he finds them out, from the internet. Oh yeah, Stolen Concepts. You won't find Stolen Concepts in any sort of mainstream logic book. Stolen Concepts was an invention of a novelist called Ayn Rand, who wrote sort of loads of stuff and had something she called objectivism. That is not mainstream philosophy or logic at all. But he latched onto that and say, "Oh, have you heard of Stolen Concepts?" He says to me, and I say, "Yeah, of course I have. It's a pile of nonsense." But yeah. That's what it is. It's just a mission. It's a salad. It's a salad. All these various things he found on various sites on the internet. It has no value whatsoever. But we know that.
Yeah, I have another question, which is that I hear something I hear repeated by the Nathan Oakley crowd, which is this idea called a necessary antecedent. I want to say that there's no such thing as a necessary antecedent. That what somebody who says such a thing is actually doing is affirming the consequent. But I'm not 100% sure that my interpretation of that is correct. And what do you think?
I've no idea what he's talking about. That's Nathan Oakley, right?
Yeah. They say, what do they say? A container is the necessary antecedent of pressure.
That's just bollocks. I mean, he's stating something as a physical, which is a physical fact, possibly as though it were a logical concept. It's not a logical concept.
Great, thank you.
I have to go at 9. So, any other questions?
One more, if you can tolerate it.
Yeah.
They also talk about ontological primitives. Now, I've taken introductory courses in philosophy. I think I know a fair amount of undergraduate level philosophy, but I have never heard of anything in ontology as an ontological primitive. I've never heard of that. I'm sort of familiar with metaphysics and epistemology at an undergraduate level, but I've never heard that word before, and I have no idea what they mean by it.
I have no idea either. There are, in epistemology, which is theory of knowledge, there's something called basic truths. I think I've got that right. But that's sort of those are facts which are basic.
Yeah,
which you just assume before everything else. But basic ontological. Sorry, what was it again? Ontological primitives.
Ontological primitives is what he calls it. Yeah.
And there's also logical atomism, which is a philosophy, a school of philosophy in vogue in the 1920s. Wittgenstein was a proponent of that. That may be what they're talking about. So rather than having physical atoms, you have logical atoms. But no, I think it's just another bit of stuff that someone's picked up. As with all of this, right?
Yeah. So it was Plantinga who introduced an idea of properly basic beliefs.
Properly basic beliefs is it? Yes, thank you, Brenda. Yeah.
Well, yeah, it's just introductory. I mean, I can't go into detail about Plantiga, but yeah.
Yeah, that's
I mean,
that's all good stuff.
yeah, he's
Plantiga is right up there, isn't he?
yeah, he's a respectable. He's a theologian. He's a theist, but he's definitely a respectable philosopher.
He definitely is. Yeah, yeah. We've got Icon Science, that is here. Hello.
Oh yeah, there he is. Welcome.
Was the cell nerve presentation, was that too basic, do you think?
No,
Did
I
it contain any
think that
useful
was
information?
oh, that was good, and I really appreciate you doing that.
I think the map stuff is interesting. How navigation and how map making proceeded is fascinating. You know, until I actually did this, I never realized. I kind of knew it at the back of my mind, but the idea that just through astronomical methods you could determine the entire shape of the American continent fascinated me.
Yeah, well, they could only make those maps if they knew where they were, right?
Correct. Yeah, they knew that, and
it's that fundamental. If you have no idea where you are, how the hell are you ever going to draw a map? And they knew.
correct.
And even like in the late 1700s, longitude was still kind of up in the air. I mean, you had a pretty good idea, but they had no way to transfer the time. So they did crazy things right around 1800 on all the sailing ships that would go from England to New York. They would take several marine chronometers with them on like an exchange basis, and they kept trying to update the U.S. Naval Observatory's clock. And when they laid the transocean cable, that was like job one, was to do a time transfer across the cable.
Yes.
And sure enough, they revised the longitude of Washington D.C. And then in all the subsequent reports talk about the different control stations through the mapping processes on their origin of time, and they would specify very high order longitudes came from telegraph time transfers, because that was the big deal.
That was the big deal. Yeah, we had Harrison's clock, which was which he developed in for a long period, ending in the 1770s. Cook took Harrison's clock K4 with him, but if you read, there's all this stuff about how brilliant Harrison's clock was, but actually, if you read Cook's narrative, his account of his voyages, actually they had a lot of problems with it. So that was in the 1770s, and as you say, it really wasn't until the 19th century that they really got a good fix on this. Longitude is not a difficult concept at all for most people, but getting the time right really is.
Well, longitude is time. So, like I said, it was the technologies of time. So
Yes.
you could get a pretty good time through astronomical observations of the occulting of the moons
of Jupiter.
But even still, that had that doesn't happen like in a mirror flash. It's kind of subjective. So you're not you could easily be off still a couple of seconds at best.
Wasn't there a competition for a really good coronagraph or timekeeper?
That was Harrison. That was Harrison's clock.
That's what he was talking about. The first time that they could have a portable clock that was reasonably stable against temperature and movement, because all we had before was pendulum clocks, and you can't put that on a ship. So he refined it to have a chronometer that was insensitive to exterior motion and mostly temperature stable. And yeah, it did a great job, but
I believe there was a fairly substantial prize associated with that, wasn't it?
Which was
like
never awarded.
Pounds,
Yeah.
It was never awarded. They offered it in the 1720s, and they were really mean to Harrison. You know, he developed this clock, but they said, oh well, it's just telling the time by accident. So that prize was never awarded. But Harrison appealed to King George, and he did get some money, but he never got the full prize money. That was mean.
Yeah.
I think he got about half of it in the end.
He got about half of it, but he'd
And
spent
and
pretty
the
much all
Navy
his
got
life.
It was
and the
an
Navy got
absolute.
100%, and the Navy got 100% of the clocks.
Yeah,
It was an absolute fortune in those days, as I recall. Though it was something like $25,000 or something like that.
I believe the prize was £20,000.
Okay.
And Harrison ended up with about 10 in the end.
Which was a lot of money
Still
then.
a fortune.
You could have bought
Yeah.
you could have bought a whole English county for that.
Oh yeah. Yeah, but without an accurate chronometer, you got a problem navigating.
Even in the 70s, they were doing the same thing with atomic clocks. There was an Air Force detail to send atomic clocks to all the remote observing stations on like a monthly exchange basis. They take one back, get it all calibrated, run it back down south. You know, maybe they were, you know, just high-end quartz clocks. I don't know, but they had to swap them out periodically. That's all time.
Yeah.
And yeah, that's the only way to measure a big distance. You want to measure a big distance? You do it all with zenith angles to stars.
Yes, you do.
Gentlemen, I have to go now. Thank you very much for listening.
Well, thank you for being here, Bebby. I really appreciate it.
Thank
I'm
you.
very grateful. So
Yeah.
I will bid you good night. Bye.
All right. Well, have a good evening.
And you.
Oh, I'm sorry I missed most of this.
Well, you can go back and watch it. It will be up on YouTube. I think it took him about 30 minutes or so. So
It's very interesting.
not a real long watch. But yeah, he told us a lot of interesting facts that many of us had forgotten.
I was trying to figure out that 182 mile zenith angle pair.
So Blue, if I subtract numbers from a quantity and then add them back, it's surprising that I get the same quantity back again, isn't it?
It seemed to be amazing to Brian's logic that he could actually do that.
I'm still trying to figure out who's going to win the cage match between the Bryans and the Nathans.
Oh my.
I'm leaning toward the Bryan only because I think Brian Leakey is actually a go to the bar and get drunk kind of guy.
Oh, he does come across kind of personable.
Oh, I think Leakey could be a fun guy to go have a beer with, no doubt. Keep him away from this flat earth horse shit and don't get off on that. I'm sure he'd be a lot of fun to talk to.
I've found that with a couple of them. You speak, you keep them away from flat Earth, and they're relatively normal people to talk to. Kind of makes me wonder how on earth they got caught into the flat Earth thing in the first place.
A lot of them are just contrarian. It's just like, yeah, it's no matter what you say, they just aren't going to believe it simply because somebody's saying it.
I find that interesting because there's a few things you could do yourself and verified. I mean, you could do the Eratosthenes measurement.
And that's there again, 99% and 90%, they don't believe their own crap. They're just playing the petulant little child, you know, yes, I am, no, you're not. Yes, I am, no, you're not. What are you? That's all they're doing. Nobody can deny sunrises and sunsets. I don't care who you are. You don't believe the sun's not setting.
Agreed.
When they say the South Pole doesn't exist, you know you're just dealing with somebody, you know, oh, it's never been proven. We don't have a video of 24-hour sun during its summer in Antarctica. Antarctica doesn't exist. You give them a video, oh, that video is not good enough. Fuck off.
Aren't there like, it's Antarctic summer down there. Aren't there like a couple hundred people at the South Pole right now?
Oh,
There won't be that many at the South Pole, but
yeah,
there'll be 30, 40.
the permanent population of the island is like over 5,000, and there's like 45,000 tourists that come and go on the cruise ships. They may only make it to McMurdo, and a subset of them go to South Pole Station, but you don't hear anybody talking about how pretty the sunsets were.
But you only go where the government lets you, and therefore, since the governments don't let us go wherever we want, like we want to wander off into the southern part of the Antarctica, right?
Go right ahead.
Therefore, it can't be real.
Yeah, the Antarctic Treaty doesn't prohibit it. Sorry.
Yeah,
Well,
if I get to 80, if I get to latitude 87, I know that latitude 90 is coming.
And the reason that governments don't let them go wherever they want is because they don't want to have to call out the helicopters and stuff to go search for your dumbass.
They won't. That's the whole point. They won't. That's why you have to have, you know, for the appropriate paperwork, you have to demonstrate some competency and that you've contracted with a rescue team, because there is no helicopter array of National Guard. That just doesn't exist.
It's really big and really far away from the nearest land, particularly like the McMurdo side to Australia and here in New Zealand. It's massive. It's 4,000 kilometers. You know, you can't fly a helicopter that far.
And it's really freaking cold and one of the harshest climates on Earth.
Yeah, they don't fly helicopters there. They bring them on ships if there are any, because I don't think there are. I've never seen a helicopter working in the South Pole. You see some C-130s and some Twin Otters.
Well, the C-130s, if I remember right, don't even shut their engines off.
No, they don't at the South Pole. Yep. And it's only the ski-equipped C-130s that go to the South Pole direct. They fly from McMurdo. And it's a reasonable flight from McMurdo to the South Pole. It's not 5-minute flight.
No, hell no, it's not. Several hours.
It's a long way. And there and back, yeah. And several of my colleagues.
It's over 1,000 miles from McMurdo to the pole, which makes the endeavors of like Amundsen and Scott that much more fantastic to go with 1,000 miles in and back.
Yeah.
In 1920.
With dogs.
And leather and brass and hardtack. And a sextant and celestial navigation.
Yeah, amazing how they did that.
Yeah, compass is almost worthless down there.
Yeah.
And Scott and Amundsen got there by independent routes and got to within, you know, hundreds of meters of each other, even though they were offset by a couple of weeks. They found, you know, Scott found the note and flag planted by Amundsen.
Well, it's real. It's down there. They can say anything they like. And yes, we've got 5-day-long time lapses of the midnight sun, so to speak. Sun never setting. All that stuff's available. They just say it isn't. And when you show it to them, they say, oh, it's fake.
And that's why I don't believe that they're sincere.
Well, they're not.
If It's a game of can you top this? They're trying to out crazy each other.
Pretty
Oh,
much.
that's great.
You can go there. I mean, you can.
It's just verbal graffiti. All they're doing is putting spray paint on a bronze statue and thinking they've accomplished something.
What gets me is who was, I forget who was, the other day someone was saying that the Army, the Navy will stop you at the 60th parallel.
No, they won't.
No, they won't, because there's no ships down there.
Nobody to stop you.
Yeah, there's nobody down there.
Nobody patrols that.
No, well,
We did
New
a
Zealand's
calculation years ago. Somebody did a calculation about it, what it would take to patrol that place. My God, you would need like 10,000 chips or something.
Well, especially if the flat Earth AE model is correct, because then the coastline becomes astronomically bigger. It goes all the way around the outside disk.
Well, New Zealand sent one of their frigates down. They were having trouble with some illegal fishing in the Southern Ocean, and this was way north of Antarctica. And they actually damaged one of the frigates. It was so rough that it bent some of the plates on the frigate. It was terribly rough, and they were chasing some illegal Chinese or whoever it was fishermen into the Southern Ocean, and they were thousands of kilometers north of Antarctica, and they still damaged the ship. It was so rough.
Yeah, there's some really nasty seas down there. The Roaring Forties, I think, it's some of the toughest. There's a few large whales, large porpoises / whales that we don't even know much about, because every once in a while one washes up in New Zealand, and that's about all we know about these creatures. They apparently live in the middle of the ocean, and it's a really tough place to get to study them.
Japan goes down there hunting whales.
Right. But even they stay out of the Roaring Forties, I think.
Yeah. Yeah, well, I got a second. I'll go.
Yeah, you're talking the Roaring
50s, Roaring 50s. I forget what it is.
Yeah, to get around the Cape.
Yeah. Nasty.
Yeah, I want to give a quick shout out to Digital Demonic Davros. Gave me $5 Australian. I lost the message, so I'm sorry I can't read it out, Davros. But thanks, man. I appreciate it. And let's see what else I can put up on the screen here.
The only comment I have, Blue, is that you missed a couple of throat clearings on.
Oh, I missed a bunch of them. I guarantee you. It sort of reminded me of as a kid. I finally got my dream job at age 15 or 16, whatever it was, at the grocery store, right? And the store manager, after a few months, decided he would put me on the weekly cleanup crew, right? Very coveted position to have. Mm-hmm. You get to work overtime and all that, or after hours. Well, and the first night I showed up, he said, "Okay, we're going to play a game. I want you to go through the store and find all of the Coke bottles that have been put up in these shelves." This is back in the days before disposable bottles. There's the old returnable types. And we had Coke machines in the store, and people would buy their Coke, drink the Coke, and then hide the damn bottles up in the shelf someplace. So he said, you're going to take a buggy, go through the store, and every bottle you find, I'm going to give you $0.25 for it. And then I'm going to go back through the store, and every time I find one, you're going to give me one of those quarters back. And I ended up owing him like $5 that night because you can't find them. He knew where to look. I didn't. Same thing with Brian's throat clearings. I bet if you go through it 10 times, you'll still find some you missed.
That was amazing. I when I saw the count, you didn't tell what the count was. Suddenly just said 1, and it was 2. I'm going, what the hell is he counting? And finally I figured it out. It was kind of funny.
I'm sorry. I just, after Brian decides to go call me a fraud, I just figured it, ridicule him a little bit. Wouldn't hurt.
I agree with Brenda, though. That was some high-level math there.
Well, yeah, when it comes to Brian, the gloves are totally off. There is no blow too low.
I could not believe the idiot was trying to subtract degrees, minutes, and seconds from decimal degrees or vice versa. Holy shit.
and just running in a circle where, you know, add some numbers, subtract some numbers he made up to begin with. Yeah. And then he just says, I measured from a horizontal, or measured from a 90. Nowhere. And then he puts up that freaking metabunk diagram, which shows two zeniths, and he's using the metabunk as one of his, you know, citations.
Yeah.
Well, I remember back when they taught us subtraction, that they taught us how to check your subtraction is you added
Add it
backwards.
back. Yeah. Mm-hmm.
And that's what he did.
Right.
So he found out that he subtracted correctly, but that's about it.
Yeah, I found it entertaining that his video goes on for about 35 minutes or close to it.
God, I can't take
So
it.
I only put a fraction of it in what I did, obviously.
Bev is still got it. Oh, go ahead, Shu.
Yeah, it's full spectrum, because he even includes a kitchen counter tabletop, you know, bad photograph thing of salt shakers and a Coke can or something. It's like, oh my God, it's like.
How 2015 of him.
Yeah, I didn't even know that was in there, and I made a comment. He goes, "Oh yeah," and then how many flirts do that bullshit kitchen counter shit? And you know, I didn't do it on a ping pong table. I went out there and worked at one scale, and then while I'm writing that, it's running in the background, the parts I hadn't bothered to watch. And it's, oh my God, he included a kitchen counter tabletop.
Bev has still got a wild hair up his backside about you, Blue. He's still going, analyzing your little talk with a fine-tooth comb.
Oh, I know.
Another
Yeah.
video.
He got.
I think another video is coming, and it'll be bad.
Yeah, he got rather upset, and he's still upset. Yeah, as has been Mobius out here in this chat all afternoon. They're desperately scrambling, trying to find a way to make the reciprocal zenith angles not work, and you can't do it. It's undebunkable. I'm sorry, it just is.
Well, as near as I can tell, Bev's whole thing is, okay, we're going to use planar geometry, which assumes the Earth is a plane, a perfectly Euclidean plane. So the Earth is flat. And if we assume the Earth is flat, which is truly amazing to me.
Well, he carries on about Euclid, right? That's like 3rd century BC. And Eratosthenes, also 3rd century BC. There's no conflict between the two. He just, you know, why not? There's no reason not to embrace them both. I don't know why he's, you know, Eratosthenes like doesn't exist or was a clown.
Well, he even cherry picks his Euclid, because one of the Euclid things is that a surface is that which has length and width. You know, so basically a surface is two-dimensional, which he doesn't like.
No, and why they fight so hard for that is just absolutely amazing to me. The concept that surfaces are only two-dimensional. Why that's so important to them is beyond me.
Well, because they bend in the third dimension, therefore a sphere is not. I don't know, Blue. It's just dumb.
It's the same logic that something could fall off the Earth and go somewhere.
Yeah. I can sense that, and the chat is absolutely right. He says, since George isn't here, I'll do the honors. Bev depends on you to create content for him. It's just classic narcissism. And it is. That it is. I don't disagree with that at all.
Well, you got in their list. I was going to say something, and what kind of list it was, but I won't. But you got on their list with the Cavendish experiment. And
yeah, that aggravated them, and it still does. They are not happy with me for that.
The success of the Cavendish it exceeded everybody's expectation. I mean, come on, that was such a deep dive, and not just a casual like you see so many other people do. And they, they're using like metal dumbbells and finding oscillations and coming up with a value for G, which would be freaking huge.
Oh, I found something you might be interested in, Blue. Let me post this in chat. It's the,
let's see. Live chat.
do we want it?
Yeah.
Okay, 1 second. Let me find it.
I think one of the things that really gets them about your Cavendish Blue is the fact that you actually recreated Cavendish's equipment.
Right.
Yes. Well, within reason, I did.
You said it's a 2/3 scale because your garage was too small, right?
Yeah, I just didn't have the floor space. That thing used up. It doesn't sound like much, 5 feet by 5 feet is what that frame is. But if I had gone to his full 6 foot long balance, then it would have been a 7 foot by 7 foot plan view. And that would have been a problem by itself. But more than that, then the height of the thing grows too. And I was out of head height more than anything.
And
So,
you did the advanced calc to say that a somewhat lighter lead ball isn't going to change things significantly. And who wants to wield around a 250 pound ball,
yeah, 350, and it was totally out of the question. The cost would have been prohibitive. I can tell you that for sure. I don't know of anyone. I don't know who I could have gone to that would have had the ability to cast that much lead that way.
So anyway, Blue, this is the gravitational constant in furlongs per fortnight. 7.14 times 10 to the 10 furlongs per fortnight. I don't know why I found that interesting, but I did.
Yeah, that's acceleration of gravity.
Yeah. And furlongs per fortnight.
Yeah. Okay. That's a big number.
Well, a fortnight's a long time.
Yeah, I was, needless to say, I was delighted with the way the Cavendish turned out with the results that it produced. It almost frightened me in some ways. It looked too damn good, You keep hoping something's going to mess up a little bit because people are just bound to say, "Oh, you're faking it. You're fiddling with the numbers somehow or the other." But then again, almost every one of those tests was on YouTube. In fact, I think all of them were. So it's pretty well documented. And the University of Tennessee's gotten even better results than I did.
They had some, I hate to say it, but they had some real scientists doing it too, right?
Yeah, the bastards. Damn
Yeah.
But is that also partly due to a better environment?
That's true too. And they do. You said they do it at night, so the elevators don't even bother it or something.
Right. Yeah.
That's part of what I was just saying about the success of what you did was the fact the university has totally embraced it and not just passed it off as this is a cute gift. Instead, it's a real instrument.
Well,
that's the impressive part.
In physics 101 or 102, the lab, they actually do this experiment. Now you don't have this piece of equipment. You got something that sits on your desk, but it gives you within reason, and you do this experiment. It gives you within reason you're a decent analog, a decent approximation of the Cavendish numbers.
Yeah, you get that with a Pascal device. You can get within 10 or 20% of the gravitational constant.
And you buy it online.
Care you take.
You buy it online for $700, and basically they grade you on how good you do that.
Yeah. Well, and UT has one of those which is now stored away in the closet, and I don't think they ever want to see it again. It is kind of a pain in the ass.
Well, if I remember, they had more than one. They put you in groups of like 4 and gave you one of these things. But it's been a long time since I did this.
Yeah. Maybe.
You can buy one online for like $700, I believe.
Yeah, Pasco charges a lot more than that for theirs, but there are plenty of other manufacturers of similar devices. And the turtle moves, wants to know if they've measured an earthquake. That was absolutely astounding. Hello.
It's me. Hold on. I'm sorry.
Okay. Yeah, and it's something the Bevtards love to aggravate me about. They come up with names like seismomadish and shit like that. I'm not sure what they think is supposed to happen to a torsion balance or anything else when the friggin' ground starts shaking. Yeah, it is going to affect it. Thank you.
Well, it is a pendulum, so it will shake. And guess what's inside? What's inside a seismometer? 3 pendulums.
Yeah, the earliest seismometers were torsion balances, actually. Not like this one. It had the early seismographs had a weight, a mass suspended at the center point of the torsion wire, and the wire held under tension. I've seen some pictures of them. They don't do it that way anymore, of course, but
yeah, no, effectively now that it's all electronic, and the servo, basically the signals, the servo loop, is that's trying to hold the pendulum in the center, and the error signal becomes the measurement effectively.
Yeah.
Yeah, you still have to have the analog thing doing the little wiggling back and forth, though. Right?
Yes, they're still mechanical. They're still mechanical at their heart.
Right.
It's just the readout that's electronic.
Right. I mean, at some level, you still got to have the little thing wiggling back and forth to figure out how big it is.
You do.
PhD Tony was doing a whole. Did you guys watch this series on earthquakes and how they prove the Earth isn't flat? It's a pretty good one.
Yeah.
It's very good. Yeah.
Excellent.
Interesting.
I like how he's getting the waves and then he's going now. He's pointing the blue dots and suddenly they hit the west coast of the United States and everything lights up, bloom, 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 because it's very heavily censored out there on the west coast.
Yeah, certain areas, and they're where you would suspect they'd be too, around active fault zones and things.
Yeah, the west coast of the United States, and then
and some in the central part of the country too.
Yeah, I know the New Madrid rift zone. It only seems to fire up like once every couple hundred years, but when it does, it's a big one.
Oh yeah, absolutely.
It should, if it goes off, it should take down, I think, Knoxville or Nashville. Which one's closer?
Nashville's a lot closer.
Yeah, flatten it.
Memphis is much closer.
Memphis on top of it.
Yeah. Yeah, exactly.
And they haven't been built to withstand the earthquake. At least not the one. It was 1814, 18. I forget.
I don't remember what the date was. That's when Reelfoot Lake was formed, though. Mississippi River ran backwards for 2 days and filled up Reelfoot Lake.
Madrid earthquake was December 16th, 1811, and lasted for about a year. 8.2. 7.2 to 8.2, somewhere in there.
Yeah, it was huge. Now they've got a big old coal-fired power plant that sits right over there on that damn fault. That's going to make a mess when if it goes off again. That's for sure. I don't think I want to be around there. Yeah, let's see. Oh, there's the Rumpus. Hey, Rumpus.
Hi, Rumpus.
Hello. Blue.
You're late.
Yeah, I'm a bit late, so I've missed it. I've missed the fun. Have you done a presentation on this or something, or are we just discussing stuff?
Oh, we're just talking stuff now. You can talk about anything you want to.
Oh, but the theme was, does celestial navigation? I think I missed this, but did Bebby give a presentation on celestial navigation on?
Yes.
Blue, right, I've missed the damn thing. Damn it.
Well, that's okay. You can go back and watch it.
Okay, well, I just thought see what's going on here then. Right, yeah, I will go and watch it shortly. Yeah, but I keep on.
Yeah, whenever
Bebby,
whenever Flurf says that the celestial navigation works on the flat Earth, I ask him why he hasn't claimed MC Tunes $10,000.
do they claim it works though? I'm not sure I've
Yes,
actually seen them. Who's
yes.
made that claim?
Let's see, the guys on 24/7 made that. I hear they claim all the time that it works on the flat Earth. Of course,
But it only works on a flat Earth.
Right, it only works on the flat Earth too. And you're going like, wait a minute, how? And of course, they can't come up with how, and they can't do the math because they can't even do a simple 3-star fix. The basis, the basis of celestial navigation, they can't do it for $10,000.
I thought they I mean, perhaps I haven't heard the discussions on 24/7, but they tend to just moan about the fact that it can't work on a globe Earth because they insist on this the level is horizontal. Like I've forgotten so long since I've seen a video on it. Now, what do they call the baseline or something? Has got to be horizontal, straight. I thought that was their main complaint.
That's
Bev's
thing.
They try to act like we're solving triangles.
Yes, I mean, it's just amazing, isn't it? No matter how many times you tell them. And, well, of course, they've got this idea that you can't measure an angle from relative to a tangent. I mean, the idea that, I mean, they don't quite realise the consequences of what they're saying is that basically if you're standing on a hill, you couldn't measure an angle. I mean, or, a point or something. I mean, it's just, but I've never actually managed to get one into a corner and actually talk to them about this because I can't get on Oakley's anymore. And Bev just disputes the whole thing works at all whatsoever. I haven't actually found an environment in which it's been discussed, actually.
Well, it's because there's not a flat earther who understands the first thing about celestial navigation. I don't think any of them have actually ever held a sextant in their hands. And if they did, they wouldn't know what to do with it.
Yeah, I mean, I think it was I was on, was it Tartaria thing or something? Was some George, one of the most stupid flat earthers, was saying the problem about, we were just trying to measure the angular size of the moon, and he wouldn't accept that you could just measure the angular size of something. It didn't matter what you were standing on. He was claiming you needed to have this straight baseline, even though you're just measuring the angular size of something. In other words, like using a sextant or some other device just to measure the angle between the top and the bottom of the moon. He seemed to think that the surface had something to do with it. I mean, you just got to get. I didn't get an opportunity, unfortunately, to present him with a diagram and say, "Look, hold on, how am I having to do this?" So yes, I've never got one into a corner where I've had access to a diagram because QE goes on about this, and so does Oakley. But of course, now that they are just so far inside their bunker that you just can't get to them anymore. And certainly I can't. And in fact, I think Oakley's been kicked off Discord, hasn't he? I don't know why. Something presumably to do with Flatty something or others, and I did try and get onto one of the QE presentation on something, but they blocked me basically, and Bev of course and I don't. Bev doesn't believe it anyway, so and I haven't. Yeah, I'll have to try and find a conversation on it and see if I can present.
Bev doesn't believe he has a sextant. Huh?
Say again.
Bev has a sextant.
No, he hasn't got it. No, he doesn't believe in the whole principle. He keeps on saying that with an angle you can't do anything. I mean, he's rather right in an odd situation. If you present him with a picture, an image, for instance, of the I think it was the Joshua Nowicki one was the one that's mentioned recently of the Chicago skyline. Bev will say, well, that's not irrelevant to anything. What does that matter? I don't understand why people are going on about it. He doesn't think the Black Swan image is in any way significant to anything. He doesn't even understand QE's argument about the Black Swan as a means to invalidate the globe Earth. He doesn't even understand the arguments at all. And he had an argument with QE about this and QE just got frustrated with him, and he doesn't believe you can do anything with angles, so he doesn't accept that the Polaris business. You can measure the angle to Polaris and it changes by 1 degree. He's not interested in any of that. I mean, he was just saying, I just caught him just now talking about how lights in the sky, I suppose. Yes, in fact, he was actually sort of umming and ahhing over whether celestial navigation works. He was saying, yeah, I suppose you could sort of possibly work out where you're going, your direction a bit, using celestial navigation. So he's in a rather peculiar area where he doesn't accept it works at all, basically. And if he did, he certainly doesn't accept that you can get anything from an angle, and he certainly doesn't accept things like the stars and things are things you can measure from. And then you've got the QE contingent and Oakley contingent who believe you've got to have a straight baseline, but they never ever do any calculations. And they just stop there. They just simply say because you've got to do that, therefore the globe one can't work. And I've never actually met anybody from the flat Earth side who actually says, yes, this is what I can do. And yeah, as you say, if they could, they'd have got that $10,000 thing from Tomb.
Hey, Rumpus.
Hey, Brenda.
Do you remember yesterday watching Bev try thinking?
Yeah.
You remember your reactions?
Oh God, yeah, he was even worse than usual. I can't remember. Oh, that's what
Absolutely.
he was even worse than usual. I mean, it got to the point where do you start if someone basically says something as stupid as that 1 + 1 = 3? Where do you start with that? I mean, he was talking about refraction. That whole bunch of them. I mean, paper on there was going. You only get refraction if you go if you're perpendicular to the layers. So in other words, you can only have a refraction from the horizontal.
You don't get refraction.
There's a temperature gradient horizontally. In other words, 10 yards from you, there's 1 degree change horizontally. 10 yards after that horizontally, there's another 1 degree change. That's the only way you're going to get refraction, was their little conclusion of how refraction works. And I didn't know quite how to start with that one. And then it just got worse. I must admit, it was one of the worst sessions. I mean, obviously, Bev is just unbelievably stupid and thick and ignorant and just science denial. In fact, he doesn't even get to the point of science denial. He just seems to. He's old, actually. Anyway, it's just a. So yes, Brenda, it was. I was stunned. I was stunned, Brenda. Yes.
Yeah. Remember what paper said, that if there's a 1 degree gradient between the front, what is it, 10 meters up or 10 feet up, that therefore refraction should be vertical, not horizontal.
Yeah. They got it completely around the wrong way. Though I must admit, it is. I mean, I've had to catch actually a number of very clever globers actually have got this wrong, who didn't understand. When describing things like the laser going through a tank, or if you draw a picture of the layers, and you say to them, what would happen if you have a perfectly horizontal beam and in the laser tank it was a perfectly vertical gradient? I've had a number of globers get it wrong as to whether or not you would get any refraction under those conditions. It's surprising that, I mean, it's a little bit tricky. The concepts involved are quite tricky, but a number of very prominent, in fact, a large number of prominent globers did not get the answer to that correct. And so it's no wonder that people like Bob on Globebusters gets this wrong. And I think Bob or Jerenism gave a presentation in which they did exactly that. I think it's Bob actually, about a year and a half ago, in which he was going through the Lake Balaton thing, and then he was saying, look, you'd only get refraction. This is why I think also that Travis also goes on about that's right. This is why Travis also goes on about refraction and the temperature difference between the object you're looking at and the observer point, because they think again it's the gradient between you and the object you're looking at that's important. And Bob did the same thing, and he actually showed in a diagram. He said, look, and he drew the gradient horizontally, and then said, look, unless there's this temperature gradient here, that's right. And he then showed that you couldn't, therefore you'd have to, and therefore you obviously, there's a limit, because if you go the other way, you've got to have a temperature, which means you're at the sort of peak temperature wherever you are to get refraction from their point of view. So in other words, if you were at 15 degrees C and you had to have a temperature getting colder, 6 miles away or something, it's down to freezing if you want any refraction. And he drew a diagram to this effect about a year and a half ago on Globebusters, and I say Bev and Paper repeated this drivel. And it's because people, as I say, even quite prominent. I could do a little quiz. I mean, I've given the game away a bit here, but I'm sure Blue wouldn't get this wrong.
I think Paper is kind of, frankly, not all there. I think he's kind of senile.
Yeah, there's something odd going on. And
He
obviously,
is
Larry
not
here knows
there
all about
at all.
refraction. And,
What?
yeah,
What, Shaky?
Pepper is not there at all.
Okay.
He start blabber every time, then say, I don't know. So why did you talk if you don't know?
The odd thing is he doesn't even get logic right. I mean, this is a guy who seems to know a little bit about Latin, a little bit about logic, and yet he didn't really understand modus tollens. He doesn't understand how to present an argument. I mean, the Dunning-Kruger level is just
Well,
astronomical with these guys.
Yesterday he had no clue and no idea why I said that Bev's level is horizontal logical argument is a begging the question fallacy.
Right.
He has no clue. And it's damn near textbook begging the question.
Right. You've got to assume the Earth is flat to show the Earth is flat.
Well, he
Well,
doesn't
Bill's
try and show
saying-
you.
Assume horizontal
His assertion is just that its level is
equal elevation.
horizontal. He doesn't claim the Earth is flat. And in fact, he just said, I heard him just now saying, he's no idea whether level is horizontal gives you a flat Earth or not, despite the fact that Blue and myself have told him about 20 times each that if you have if an elevation profile, if an elevation forms a straight line, in other words, points at the same elevation point form a straight line, that means the Earth must be flat, because if 10 meters, if all the points of 10 meters above the Earth form a straight line, well, that means that the Earth, the reference point, the reference surface must also be a straight line or a flat surface. But apparently that's beyond them.
Well, there's a lot of things that are beyond them.
Indeed, yes. But that one's particularly, because I mean, I would have thought that argument would be, I mean, I think a sort of, 7, 8-year-old, if I said to them, well, look, if all the points, this forms a straight line, what does that tell you about 10 meters below that, for instance? What shape has that got to be? If all the points of 10 meters form a plane or a straight line, then what does that mean for 10 meters below that? What's that going to be? What shape's that going to be, matey? And apparently that level of argument, well, I don't know whether Bev just doesn't understand it, or he rejects it because he knows that if we were to say that was, I mean, he's sort of, and he's also accepted. I said on one occasion, if I said a 7,000, I used to go on about a 7,000 mile length canal. Would that be horizontal, the surface of that canal? And he did dodge it about 20 times, as he does. But at one point on the subsequent day, he said, well, it'll just sort of carry on being horizontal. And then he doesn't understand that then means it must, therefore, the Earth's surface must be horizontal. I mean,
my favorite is where they take out the elevation profile, the graph of distance versus elevation, and say, look, it's the Suez Canal is flat. This diagram proves it.
Well, this is what QE did about 2 years ago. I don't know whether he got it from QE, because that's when there was a revelation. There was a big Oakley QE Live, whatever it was, revelation that had been promoted, trailered or something the week before, that QE was going to come up with this marvelous revelation. It was that the globe Earth, Google Earth, is a flat Earth model.
Yeah, I remember that one.
I thought that was the most ballsy move I've ever seen in my life. I mean,
I watched that live and was laughing my ass off. Oh, so it's zero. Let's see. The elevation is sea level in England and sea level in New York. Therefore, it's flat between those 2 points. Gotcha.
Yeah, but if you look at the elevation profile, look at that lovely horizontal baseline reference. There it is. It's always horizontal, isn't it?
And Blue was the one who pointed that out. He unpinned it from the. You did the unpin thing where and then you can see the difference.
When you go to an absolute elevation instead of clamped to the Earth is the term Google Earth uses. Yeah, then you see the curvature.
From a grifter con artist point of view, you got to kind of admire it. I mean, to actually go in public and say that with a straight face. I mean, he can't possibly actually believe this shit.
Well, they do.
I was laughing
that
whole time. That was one of the best laughs I've had. I was just laughing my ass off, going like, "No, this guy cannot be fucking serious."
And the trouble is, when they go to that level, it's like someone saying, as I say, someone coming to you say 1 + 1 is equal to 3, and you don't quite know where to engage with the argument. You don't quite know what to say. Where to begin? Where's the common point? Because in an argument, you try and find a common point of where, right, we'll agree on this bit, and then you lead them on to the next point. But with that, And also it's undermined. You're not used to thinking down to that level. You know, you're not used to going diving into that level of misunderstanding. And George and I discussed on many occasions. It sort of destabilizes your thinking for a bit, where you think, how do I tackle this argument when they're saying something? Like, you do know that the Google Earth is spherical, isn't it? When you zoom out, but of course they then say it changes or something. I think is their argument. And of course, Bev doesn't understand this. I mean, he was shocked when I told him that the elevation profile was based on arc, and then Blue actually had some public debates with him about this very thing, that the elevation profiles you see, that just because it's horizontal in the screen or on a piece of paper, that doesn't mean to say it's the distance along an arc, actually, matey.
It's a graph, yeah.
Yeah, it's a graph of elevation against distance. So that doesn't mean to say the distance is horizontal.
Well, Bev's argument is like this. All horizontals are parallel to the plane of the horizon, and there is one plane of the horizon, right?
Yeah.
So I tell him, okay, so Earth is flat, right? What's the horizon? It's the water and the sky. If the water is flat somewhere, then everywhere, then Earth is flat. He says, no, have you ever heard about tides and waves? Fine with me. So where is this plane you're talking about? There's tides and waves. When is it horizontal? What time of day is it horizontal if there are tides and waves?
You know,
He refused to accept the consequence of what he says.
Exactly.
They're gonna listen to this and they're gonna say, "Oh, look at these guys all talking about how stupid we are," and they're the stupid ones. You watch.
Yeah, well, that's what they did whenever it was. They reviewed. Was it Blue's? No, was it Toon's video recently? Oh, no, it was our discussion. That's right. It was actually our discussion last week, or was it last Tuesday or something?
Yeah.
They were going through it. Yeah, and they were just doing basically that. And Page, and they still don't I tell you, Blue, when I'm going to get when I get round, life is impinging on him. But when I'm going to get Essie Montre on these other ones, I'm gonna hammer home the idea that verticals are radials, because they haven't got onto that level yet. Even though I shouted at Bev about this, a year and a half ago. Do you understand that on the globe model that down is towards the centre of the Earth and therefore is a radial? And he did claim the next day, although he wouldn't accept it at the time. It does this again, where he just prevaricates to avoid answering the question. But then the next day he did sort of say, "Yes, I do understand that." And of course, I think Blue obviously believes he does understand this intimately, and he's just trying to fool everybody.
That's precisely what reciprocal zenith angles show you. They diverge above the theodolites.
Well,
those lines are diverging. What does that tell you? Go back to Euclid. What does that mean? That means they're converging and intersecting on the other side. What does that make them? They have to be radials. They can't be anything other than.
They didn't understand that, though. I mean, they went through your presentation on this, and just the comments. They didn't. They said, "What's this angle?" They did not understand what you were doing. They did not understand what you were doing. Just incredible.
If I were you, I wouldn't waste my time with Yogi, though. He's not the world's brightest bear.
Yeah, but it was fucking 5 hours long, though. Holy crap! I couldn't.
Yeah.
S.E. Montreal. He reminds me of Yogi Bear with his cadence, the way he speaks.
Somewhat.
Although he might be stupid, he's not quite as devious as Bev. So I think he's more honest about his stupidity.
S.E.'s too stupid to be devious. S.E. is not bright enough to be devious. All S.E. can do is just repeat the shit he's heard.
I think there are dimmer ones than him, actually. I think there are. I mean, something like, is it Gadget Inspector? I think has to be the bottom of the barrel. There's a couple of other ones that are even worse.
Oh, we can say that.
I think Essie's mid-range. I think he's mid-range. Bev,
Gadget can draw very nice pictures. I told him to focus on that subject, what he's good at, and forget the things he's not good at all.
And Paige is worse, for instance. She seems to understand less than he does.
Paige is a Southern Hemisphere flirt, so she's like definitely at the bottom of the barrel. How can you live in the Southern Hemisphere and be a flat earther? Just go outside, look at the stars.
Yeah, no, so actually isn't one of the worst, actually.
Paige had the mother of flat earth.
Hey, shout out to Judy Bassett for a $15 PayPal. Thank you so much, Judy. I appreciate it very, very much.
Yeah, Blue. I mean, I think this is where I think your where you could have done with some interactive diagrams when you went after in your debate with Bev, because you did it. The excellent video was, I think, was excellent. Except that for them, I think it's confusing. Had lots of numbers in it. But I mean, you wanted to provide a nice reality-based argument, and they never even mentioned it. You never got round to actually discussing the fact you were showing them reality. And it was contradicting their claims. It just ended up with them being quizzing you about whether the perpendiculars at the end of a horizontal line, a tangent line, were vertical or not, and asking you 20 times how to do it. But damn it, I forgot my bloody point now. Oh yes, interactive diagrams. You see, that's why I think hopefully I will have a bit more success, because I will, someone like Essie might make a stupid point, and I would say, okay, let's go and look at the globe model, let's draw it out, and then, oh dear, you're wrong. So I'm not saying it'll absolutely work on all the issues, but I think you see, with Bev, a lot of the questions that he was asking you, and you were trying to. Hold on, wait,
Rumpus, we heard it before. We would never know unless you do it.
Yeah, okay, but I'm just saying that it would have really helped you to have some diagrams where you could draw what he was describing, and then he just asked you the same situation, same scenario 20 times. If you could draw it out, then he said, "There, look, this is it," and then you could just look. We've done that. We've already discussed this thing. There it is, there, and you're an idiot.
So, Blue had enough rough time with the video, and posting this on YouTube, and you want the interactive diagram on top of that.
Yeah.
Which it's always a problem, and you can't handle it, right?
I can't handle it. What? Sorry, I've said it's.
You always mess it up.
I don't know. Thank you,
Yes,
Chucky.
you do. Yes, you
That's
do.
not true.
Where is
you
this? Where is this? No, this doesn't work.
You little devil, Chucky. That's not fair. I do not always mess it up.
You want me to find videos?
Yes, I do not always. I get it. It does take me some time sometimes to draw it out, but I don't know few other people actually try and do it live with a proper diagram. But I think I'm reasonably competent now. Thank you very much.
No, we'll see.
Okay. Well, that's me, cheeky bastard. Yeah, I think I'm reasonably competent in that regard. Oh, well, we'll see anyway.
Yeah, see if I just put something in the chat there, courtesy of Larry. You sitting there, Larry? Are you available?
Yeah.
Why don't you tell us what we're looking at?
Oh, you little devil! Your diagram there is very similar to the one that I was showing. That Blue didn't actually show last Tuesday, whenever it was.
Well, but to his question there about this diagram, yeah, that's the triangulation report from, as it's titled, from the 39th parallel done in the 1890s. And there's two intervisible points, and they're not all that far apart. I mean, like 65 miles apart, and both the vertical angles, or zenith angles, are greater than 90. And obviously one's much lower than the other, but they're both less than 90, or less than horizontal, or below horizontal, because they're greater than 90 from zenith. Again, no horizon was observed. And this is from, like I said, 1887. And so when you look at historical work and recent work and current work, there's no big deal going on here. It's all the same. I mean, you look at the refraction constant of 8.4 seconds. I got 8.0. So again, and that's based on my observation.
Oh, you got eight. You got
just the pure math.
Sorry, Lau, you say you got eight something or other seconds for what measurement?
A refraction constant.
Oh, I see. All right. Okay. So
They say we don't know what refraction is. They say we don't know what refraction is. Oh, and it changes and varies every day, so we can't make any use of those measurements. but it doesn't change by much.
So you're talking about
It
the K
doesn't
value
change
here, are
by-
you? You're
Pardon
talking
me?
about the coefficient, the K value, the coefficient of refraction.
Well, there's
No.
the coefficient of refraction, which is not, and which was kind of embarrassing. I was talking to Jesse about it, several years ago. I didn't really understand what it's a coefficient of. It's just something that you put in the software and all this good shit because we're software junkies. The coefficient of refraction is a coefficient of the central angle at the center of the Earth. So if you look at the
Well, it's the
rate-
reciprocal of the
length-
radius. It's the reciprocal of the radius divided by the reciprocal of the radius of the refraction of the curvature due to refraction over the radius of the Earth. That's what K is, the coefficient of refraction. So, and it's normally about a value of 0.16 or something for the standard refraction, but it can go nuts. If you've got something in other words, for the black
Okay.
swan scenario, it's actually a value of
wait.
1.
No, stop. The coefficient you just cited was not the coefficient of refraction used in land survey. Okay? The values are typically about 0.07, 0.075 under one definition, and twice that under another definition. So we're talking like 0.15. We're talking two very different things.
Must be okay.
But
Well, the one
the
that's normally
coefficient-
discussed, you might
Okay,
have
the
one thing when you're
coefficient-
surveying.
The coefficient of refraction is that fraction of the central angle at the center of the Earth. And that is carried forward normally as how it's calculated, and it doesn't change a lot.
Yeah, I think yes. I think I've seen in some surveying books when you try and allow for refraction, you don't use the K value. If you look at scientific papers on the issue, they talk about this thing called K, which is the coefficient of refraction, which is 1 over the radius of the curvature, and that times by the radius of the Earth. So it means if you get a value of 1, that means that the ray is following the curvature of the Earth perfectly. It's got the same curvature as the Earth. So that's what you've got called when you get something called circulating rays. In other words, that's what the black swan situation was, where in theory, if the light went for far enough, you could see your own bottom. Because it go around the Earth and have the same radius as the Earth, and if there wasn't due to degradation of the light ray, and it wasn't anything in the way, mountains or whatever, you could, in theory, and you had sufficient magnification, you could, in theory, see your bottom. But that's so K value of equal to 1 gives you what's called circulating rays. But yes, I think I may have seen something in surveying literature which is a multiply, might be different. But normally in the scientific literature, when they're talking about refraction, the K is normally 1 would give you what's called a circulating ray, i.e. the same radius as the Earth. But we're obviously working two different things. That's what you.
But by the way, Clary, if we do calculation for Bev's famous thanks Bev picture, we also get 43.6 arc seconds.
Yeah,
Around 43 arc seconds.
Yeah, it's not hard. It's not hard, and it's highly replicable, and it doesn't vary grotesquely under what they call standard refraction is standard conditions. And the standard conditions is, not the dead of winter, not your hottest frickin' day you can find, and not close to the water, the light line of sight, not skimming terrain. You get very consistent results. Yeah, it could vary, a second or two here or there, but not going from, completely batshit and unusable unless you get really close to water. And look at the black swan photos. All the ones they be bringing up, either at night, dawn, or sunset, when the sun is low or not there, and that's when refraction is highest, not least.
Absolutely. Absolutely. There's a classic paper by some German surveyors showing the refraction over the duration of the day using reciprocal zenith measurements, and then because they know the radius of the Earth, you can then work out what the refraction is, and they show that the refraction goes nuts at about just after sunset, and it gets to this value I was talking about, +1, gives you a circulating ray. That's the radius of the Earth. In other words, a black swan type thing. And they got up to plus 16. And George, when he did his observations, he got up to a value of something like plus something similar, plus 3 or whatever.
Yeah. So right. So in the observation of the shape of the Earth to determine elevations of distant points, yes, these things are all well known and well studied and applied. And in this case here, the zenith are definitely diverging, and refraction makes them a little more apparent. It increases the effective apparent radius to about 4,700 miles instead of 3,960. So yeah, this is well known. I was this example here was because of between Bev and Brian's illogic is all the fraud and fabrication, reverse engineering. Well, this is a document by the highest of science organizations, Coast and Geodetic Survey of the United States, and they published the measured values for the world in the introduction. They said this triangulation across the continent isn't for internal use. This is published to the science community.
And
Didn't they do the same thing for India too, Larry?
The UK when the East India Company did the triangulation of the great arcs of triangulation across all of India. Yeah, that's a no holds barred piece of science work.
This is what has amazed me more somewhat, that people like Bev and Paper try to maintain that what you and Jesse did was just a one-off. Nobody's ever done this before. Well, Jesus God, fellas, here's stuff done back in the 1800s where they were doing reciprocal zenith angle measurements. It's a normal thing to do in geodetic surveying.
Bev does this a lot, doesn't he? He'll say that when you've said something, or it's a dramatic new development, oh my God, it's groundbreaking. When I've said a number of things, said, oh my God, this is groundbreaking. And my wrecked observation, Bedford Levels, he keeps on saying, oh my goodness, this is a brand new thing. Well, I'm not really. I don't know whether Bev is just trying to dramatize and sensationalize the interaction he's having with someone else, as though he's trying to make this some sort of new and novel and groundbreaking for his ego or something, but he doesn't seem to recognize all this work that's been done hundreds of years ago.
Yeah, well, he said it before. I heard him on one of his shows. He said it's something was invented by Globers to argue against like it's a recent thing. Yes, just recently they start arguing it.
Yeah, just like everything is NASA's big lie. This shit predates NASA like by so many leaps and bounds. NASA never came up in the conversation.
Yeah, they were measuring the reciprocal zenith angles a century before NASA ever came around. They were doing these measurements back in the mid-1800s.
Yeah, this is before then. I mean, 1760 France, the Academy of Sciences, Paris. I mean, they triangulated, across the all of Europe.
Yeah. The Meridian Arc of Paris, I think they did that too.
Yeah, that's the one. And then they sent a team to Ecuador. They sent a team up to Lapland, and then they contracted with Mason and Dixon to redo the Maryland-Delaware border to a higher specification because it's a 150-mile portion of meridian, and they remeasured it under contract to the Academy of Sciences.
Blue, I've got this diagram that I was trying to show last whenever it was, and you didn't quite capture it, which is actually rather similar to the diagram that Larry was showing here. I don't know whether you were showing it earlier, that he was showing about horizontal and constant elevation. If I could could you show it?
Yeah, I can if you stick it in the live chat.
I'm streaming.
Oh, you're streaming. I'm sorry.
All right.
In that case. Yeah, there you go.
Right. So the thing I was trying to say last time, and it's very similar to the diagram that Larry, posted just a few minutes ago, which is about this. It's something which is similar I've shown before, but it's in a bit more graphic detail here. And this is the thing that basically was also related to the presentation you gave to Bev and his quizzing of you. And this is the sort of diagram that I would hope to present to him and I think it's quite good, despite Mike Chike slagging me off. So here we have at the top. Let's deal with this one first. Let's just simply say this is the scenario that Bev likes to describe. Here we got, or he can almost cope with this part of it, which is, so here we have a zoomed in part of the Earth, and here we have a plumb bob. And as we all know, if we're at point A here, that the horizontal for A is going to be perpendicular to this vertical, which is as indicated by this plumb bob I've drawn here, and therefore I've drawn that's horizontal for A. So there's point A, point A, and then we have this horizontal, which is a plane. So all the green things in this diagram are planes, and all horizontals are lines. Lines. You can only have vertical lines. You can't have vertical planes. Verticals only exist as lines, and horizontals are always planes. And so if you were to put a level, spirit level, at point A, it would show you the perpendicular to A, which would also be a tangent as well. That's incidental, but it's worth mentioning. And so this green line, which I've written horizontal for A, also has other points on it I've drawn on it, of B, C, D, and E. And if we then were to draw perpendiculars to them, which I've put as P here, PB, PC, BD, and PE, these are the perpendiculars to these points A that I've arbitrarily picked on along this horizontal for A. So this is green line here. This is all horizontal, like all the points. And this is something that I think I was quizzing PhD Tony. We were having a slight debate, weren't we? I was saying I disagree with him slightly. That all these points here along this green line are horizontal to A, because that's on the plane, and all these points are on that horizontal. And what's more, where I've chosen at these arbitrary points, though, you can see that we've changed elevation. I've got previous diagrams to this to explain why these levels are changing. But as you can see, points B, C, D, and E, they are, I've then drawn in these pink dotted lines. These are points of equal elevation or level. They are level. In other words, if something's of equal elevation, it's level. So we've got, I've called it LE, LD, LC, and LB. So all the dotted line there represents a level, and they're all of the equal elevation. That means, we'll go with a moment, from the same distance from the center of the Earth, and they're basically just concentric circles around the center of the Earth. But it's not quite that, because I haven't allowed for the bulge, but it'll do for the moment. So on this diagram, we've got a horizontal, we've got a single vertical, we've got some levels of equal elevation, and then we've got these little perpendiculars at various points that I've chosen a uniform stepping, and we've got these perpendiculars. So the thing that Bev doesn't, the two lines of attack he then was saying, and he was using it against you in your presentation, was, well, okay, this PE, well, that's obviously perpendicular to vertical for A, because the vertical for A here, obviously this line is perpendicular to the vertical for A, so obviously this perpendicular is then parallel to the vertical for A. So then we've got these lines here of perpendicular to the horizontal for A. So the question is then, are they vertical? And of course they're not. For a start, they're changing in elevation. So I may have to simplify this diagram. So I saw someone in the chat was moaning about my diagrams being too complicated. I think this one's got possibly a bit too busy in it. George would probably complain about this as being a bit too. I might reduce the number of points. But anyway, so we've got these. I'm now, if I were to put a level on these various points, you would see that then you would get these other verticals. The vertical for these points B, C, D, and E, they're the same points as they were up here, and I've preserved the perpendiculars here. Those blue dotted lines are the perpendiculars at point E, D, C, and B, marked P, B, B, C, B, D, E. But if you put the level there, they are not aligned with the horizontal for A. So the green line horizontal for A is still there. But if you were to put a level there, they obviously are going to be perpendicular to their own personal local vertical. And I've drawn those in as VE, vertical, VD, VEB, all pointing to the center of the Earth, because as any line that passes through the center of the Earth, it forms a vertical. This is something else that Bev couldn't cope with when I mentioned it when he was commenting on in our review. So any line that passes through the center of the Earth is a vertical. And so the vertical for this level at E it's got to point to the center of the Earth. It's a radial. The plumb bob, if I were to hang a plumb bob at E, it would point to the center of the Earth. It'd follow this line VE, vertical for E. That's where down is, and up is obviously the opposite of down. And there is the perpendicular, E. So, although this point, E, is on the horizontal for A is not on the horizontal for E, because E's horizontal is this green line, HE, because again, the green lines are the local horizontals. So this is the horizontal for point E. So point E, this little green line, which is a tangent to the level. So it's on this level, LE, and the horizontal at point E is HE, but the point A is not on this line HE. Line HE, if I were to extend it, would be up here. Perhaps not to do that, actually. That's possibly something like to make the point, actually. Yeah. Could improve that slightly. So, so they then say, they regard it as a contradiction. They're saying, hold on, you've got something at point E, it's on the horizontal for A, but it's got a different horizontal and vertical. So therefore, they claim it's a contradiction. Yes, because all we've got here is the horizontal laser plane. It's on, and there are an infinite number of points. There are lots of. I'm going to show a different diagram for that. But just because point E is on the horizontal A, that does not mean that point A is on the horizontal phi. The local horizontal and vertical is orientated as I've drawn here, and also, of course, it's got a different elevation. LE. These points are different elevation. So anyway, that's what the Jesus Christ.
What happened?
I think he just got hit by an asteroid.
Or he got
Yeah.
swatted.
Well, I've heard that. I've heard a similar expression on those cockpit tapes right before crash.
Well, you see the problem with interactive diagrams? I made my point.
He's still connected. Yeah, I hope he bought his Raptor insurance. Whoops.
But why we need this? We had the blue showing the horizontal intersecting a higher point than where Bev is. If you don't accept this, you won't accept any diagram.
I ran out of memory.
Oh, goodness.
Did you get it till the end when I said?
Yeah.
Right. Okay.
We got to the end where you said Jesus Christ.
Okay. Right.
We
yeah,
got that part. Yeah, we got the Jesus Christ part.
Yeah. Anyway, so that's the sort of diagram I'm proposing, despite Chaiki's complaints. That's the sort of diagram I'm hoping that will make some sort of progress with them. But let me see.
So-
Well, it's
I think
very
that's
textbook
wishful
looking.
optimism.
It's very textbook looking. Your graphic work is, stepped up a notch. I mean, it's kind of pleasant looking.
Jolly good. Yeah.
Yeah, I
could
like
probably
it.
do a little bit more. Jolly good. Yeah. I mean, I've had that around for about a year and a half, actually, parts of that, but I just haven't got round to organising it into a video because I keep on doing something new and being distracted. And
Oh, you saw the little half-assed sketch I put up there, and that was just based on my own measurements. I didn't have a carpenter's level.
Well, of course, you'll have to watch YouTube to see this, but because I don't think I can share all. I'm not even going to try. But there's a really simple sketch. I'll tell you when it shows up. It's on YouTube now. The really simple sketch that I've been showing these guys, which is it's not just a drawing something in theory. It's what we can put numbers to. We can measure those angles and prove that those radials are radials. And that's what's killing them.
That's why I was pleased to come across out of that myriad of angles where I could start to find them in pairs, because the way they tabled it's really hard. So to find them in pairs to where, they're both exceeding 90 degrees in zenith.
Yeah. Not by a little bit either. a good bit.
Well, I couldn't believe it. I was just browsing through it, and I realized one was 182 miles long.
Man Devil's just claimed that I get things wrong. I'm sorry. First rule of the internet is I don't get things wrong. I draw things incorrectly, if that's what he means, or sometimes I trip over. If that's what he means by getting things wrong, cheeky devil. God, I'm getting some slack. I'm getting some slagging today.
Just get this presentation over with SC Montreal and who else?
Two others, Arskin and Mobius was the original plan for the thingy.
Oh God.
And that doesn't include the diagram which I've got about showing that there's no contradiction between having a hump or sagittar and the drop. There's another diagram, many other diagrams as well.
I don't think SC Montreal going to give his paradox.
If I do it slowly enough, if I build, I mean that's quite a complicated diagram. Possibly I made it more complicated by putting too many of those levels. I could reduce that to make it less visually complex.
Yeah,
But
three would be enough.
Yeah, I think you're right. The trouble is, it takes as much to remove something in that and make it neat as it is to add it in. It takes me bloody ages. I mean, I can do these things, but it takes me bloody ages. So these graphic artists who can do it quickly are very skillful, but I just take a bit of. I think it's an awful lot of effort for me.
Be much easier to draw it in AutoCAD.
Yeah, it's just where you've got some redundant things. You know, you don't have to put a level on every one because, you know, but
you do.
Every other one.
I've noticed this. You see, for instance, if I just put a plumb bob on one of my other diagrams, if you just put one plumb bob, it doesn't make the point. They think, oh, there's just one plumb bob.
I didn't say one. I just said maybe a couple.
Yeah, I mean, it needs. Yeah, I'll go as Blue said. I might reduce it to 3 or 4 points on the along to make it simpler, visually.
Well,
less
or
complex.
the graphic of the level, you know, could be, you know, like every other one.
No, I don't. I've decided against that sort of
All right,
economy.
You're drawing, and it looks pretty nice.
Yeah, thanks. Yeah, I could make them smaller. It is too visually complicated. I think that's what you're basically saying. But I think if you make something that's different between one point and another point, then I think it's very important to stress. For instance, I always draw things at the sort of 2 o'clock position on globes and things, to make the point it's not vertical, and to make them think, hold on, why is this at an angle? And so they don't. And I also believe in making everything consistent so that every point looks the same. So that I'm trying to make a uniformity of these situations, and not trying to say, oh, if you're at the top of the diagram or at one point it's different from another point. And I'm trying to hammer that home. Perhaps that's the reason anyway.
It does show a lot of understanding and a lot of work. It's a nice looking drawing. Don't change it.
Thank you, Larry. That's very kind of you. Yes,
maybe it's a bit of scale. You know, have it. You know, the text somewhere else so you can make it bigger.
Yeah. I mean, I think you're right. It does need improving in terms of simplify. I just need to remove more of the things. It is too visually complex. George was always complaining I made everything too busy, as he put it. And then I told him he was a bit cheeky because he never drew anything, and then when he got round to trying to draw these sorts of diagrams, he had terrible trouble. So I mean, I was saying when it takes me, I mean, Chaiko's basically saying I take time to draw it, but you try it actually. You people who think you complain when you try and do it live and draw these things. It's quite tricky to do.
That's why I said it's unneeded. There are more simple ways to show Bev he's wrong. Much simpler ways.
No, they can't understand verbal explanation. I've decided the only way they can understand something is if it's visually presented. So something like the diagrams that Larry's been showing are excellent to do their point. But they've got to be visual. They've got to be comprehensible. Yeah, it's just a matter of I think. I think the only way to was with a and if you make some inconsistencies, I say if you started doing things differently to different positions, because I mean someone like Bev, we know that he will willfully misunderstand anything, and there's been some diagrams that Blue has done in the past where he hasn't put in all the verticals and all the horizontals, and he's thought, well, any normal, sensible person would fill in the other bonus, the bits that I haven't filled in, but they don't. They then pick on that, and so I think you've got to hit them hard, and you've not got to allow a tiny little error anywhere, and so there's almost unless they sort of disregard in the diagram, they just cannot misunderstand it. But anyway,
well, they're going to.
You're very optimistic.
No matter what you do.
How are you going to misunderstand a Bev's own picture? How can you misunderstand it?
On some things, I say that the one that little presentation I gave there for a few minutes, that is capable of being misunderstood unless I go through it really, really slowly. I mean, I went through it a little bit more quickly because obviously you guys know it all anyway. I would develop it more slowly but the things like the drop versus Sagitta problem, I'm going to have one diagram and show to SE. Look, those two things you can see on screen are there in a globe model, therefore they're not contradictory, and that is going to be a comprehensive one down, because I don't see how he can get that wrong. But anyway, we'll see how I get on when I finally get around.
Oh, it's easy. They have no problem getting that wrong.
They can get anything wrong.
Yeah,
well,
absolutely.
but he says it can't coexist. And when you can show a diagram and say, look, I've got the bloody drop line, I've got the bloody Sagitta line, the hump, they're in the same diagram. You can see that there, so it can't be a contradiction, can it, SE? It's like you're looking at the fact that it is not a contradiction. So I believe on that particular subject.
Yeah, here's the difference in the approaches. Though you're still trying to teach them. You still think that you're going to get them to come around to your way of thinking. I'm not. I'm just ridiculing them. That's all I'm doing.
Well, I like to do both, I suppose.
The people who are the people who are not clinically or criminally stupid know exactly what I'm saying, and all I do it for basically is just to ridicule those fools. I'm over trying to teach them anything. They refuse to learn, so to hell with that. But go ahead, feel free. I mean, have fun. Maybe you can do something with them. I sure as hell haven't been.
Yeah, because I think you've gone. I've noticed this with Globers. They go from one extreme, like the cats, this one, and to some degree yourself, where you've tried to be really nice, tried to be really slow with them, tried to explain it, and then when you find, because I mean, when you did it with Lion's Logic a year or so ago, and you got punished for it, of course, when you tried to be desperately understanding and you were trying to accommodate stupidity, and then you sort of explode, and then you get all cynical and say, right, that's it, you bastards, I'm just going to abuse you and not try. Whereas I think I've had this middle approach all the way along. I've realised that they're stupid. I'm prepared to say that, and then go for them. And I've stuck with a sort of constant view of this, where I still try and teach. I believe that I have the skills sufficient to teach something anyway, because I haven't changed their opinions on some things in the past. But yes, obviously something like the more complicated stuff is tricky, but I'm sure some of the simpler things, I'm confident. But anyway, we'll see.
Wait, they may have changed the opinions of things in the past, but then they change them back. So
yes, there is the reset. You're absolutely right, Chaiki. There is the flat earth 3. I mean, Katz is an example where he's super kind, and he's now gone from trying to accommodate them down to being super agitated. Perhaps he's got the sort of like a work profile where you get really worried, really excited with work, then you get depressed about it, and then you finally come to a sort of level point where you've got to you live with the situation. I think possibly Katz is going through that situation now. He's gone through the kind, gone to the extra nasty, and I think he'll probably pop back to somewhere in the middle, where in between the two. Because he seems to have.
That's just my. That's what I have evolved into over the past few years. At the moment, they're nothing more than chew toys to me. That's all I use them for.
Yeah, that's understandable.
The problem you have is, can you really tell that they believe their own shit? And
that is a tricky one. I mean, Blue.
Yeah, how do you tell a con man from somebody who's stupid? Very difficult.
Because I believe the answer to this, I think we discussed this last week. I believe that Bev says lots of stupid things about things that are not controversial. So, for instance, he got these miles mixed up. He couldn't work that out. And there's some other subjects where he doesn't understand simple logic on some things. And so there are lots of other side subjects that he gets completely wrong, which demonstrate to me that he's stupid. Whereas Blue thinks, I think to some degrees, he's not got a mastermind, but he's being. I mean, the thing is, he's a deceiving little git. We all know he does that as well. But I believe fundamentally his problem is stupidity. And of course, the thing is, if you are stupid and you want to believe in something, and you don't understand that what you believe in is wrong, then and you can't understand someone explaining to you that something is wrong, and then when someone like Blue presents you with evidence that you're wrong, but you don't understand it, you can still revert back to, well, I didn't understand what was Blue just told me, so I'll go back to what I wish to be true, and you don't have to worry. Whereas someone like you and Blue and myself and Larry, if we find something we believe to be true, and then we find some information that contradicts it, and we can't refute that information, we go, oh dear, oh, I'm going to have to change what I think. Whereas they don't get in that problem because they don't have to understand this external information that's coming in. They can just reject it on the grounds, I didn't understand that, therefore I'll just stick with what I want. So it's difficult to tell. I agree, but there could be the supercon men. I mean, someone like Nathan Oakley is more. He's capable, I think, of being more in that camp. But even then, he says stupid things. He can't work out to get meters to kilometers, and he denied refraction existed. I mean, his argument before 2-3 years ago about the Isle of Man was that refraction wasn't a thing. Now he says it is. So clearly, I mean, to not accept refraction means that he's obviously very stupid. And so even someone like him, who there's been some suggestion he's just doing it for the money. And again, it's a combination. He is stupid, and perhaps he's doing it for the money. So, but I don't think they really understand what's going on, and then just pretending to be fools because they're foolish in all sorts of ways that you wouldn't make. I mean, QE and his bloody the Google Earth is a flat Earth model. No one who understood that what was true would not make that stupid statement. As Brenda said, this is so brash that you can't possibly know the truth to be making this. Although, unless you go to Hitler philosophy, which is if you want to get away with a small lie, tell a bigger lie to cover up your small lie. But I mean, I don't think these people are that clever.
But they do get to a stage where they tangle themselves up because it's lie upon lie upon lie, and you do see that in con men. That they eventually tangle themselves up in a knot because the lies become contradictory, and then they try and work their way out.
But I don't think they see the contradictions. I don't think these people see the contradiction because you and I can see if I told Blue that he'd contradicted himself in one of his things, he'd go, "Oh my God, what did I?" And then he'd go and check it, and if he found out he had contradicted himself, I'm sure Blue would go, "Oh bloody hell, I'll have to go and do something like that." Whereas they don't have the intellectual capability of working out they have contradicted themselves for 90% of the situations they're dealing with. They sort of wiggle round it. I don't think they believe if they really recognised there was a contradiction. And they had morally they thought contradictions were bad, they'd do something about it. But either they don't recognise a contradiction as a problem, or they don't recognise there is a contradiction. I mean, because they're stupid. I think they're basically.
Come on,
stupid.
get serious. One day, Bev says, horizontal planes definitely exist in reality. In definitely exist. And the next day, we talk about Euclid and planes, and I said, wait, you said 2D is not reality. I said, so how do you have planes in reality? He says, you don't. Now, there's a contradictory to you.
I thought he said they do exist in reality, and it's on the globe.
Well, he said both. Whatever suits him that moment, he will say.
Are you sure? Are you sure he wasn't referring to the globe?
Wait, hold on. I'll post it.
Okay. Because I thought he's definitely made the statement on a globe model he can't have a horizontal. Quite why he thinks because I mean the only horizontals we ever know we've ever met. In fact, I think Blue had made the same point. The only horizontals we ever see are in LIGO and through an auto level. We don't meet them otherwise. So they only exist in terms of an abstract thing.
Yeah, it's a concept. It's an abstract concept, really.
Yeah.
I can't go down to the store and buy a horizontal.
Yeah.
And I can't buy anything that will show me a horizontal if it doesn't have a way to reference itself to gravity.
Yeah. I mean, it's so weird the fact they go down that line where
That's simple.
And again, with this stupid business about not being able to get an angle except with reference to a horizontal plane. I mean, these arguments are so stupid. You cannot be a con man and be making these sorts of arguments, because we can obviously see you can measure an angle with respect to the horizontal in a theodolite or with a sextant. You can, simple, but this piece of geometry shows. I mean, if you're a con man, you would not be making the sorts of stupid arguments that you've got to have a level horizontal baseline to work out the angle to a star, because we then know that means if you know the distance to this GP and you've got a triangle, we'll end up with the height. With an angle and the distance, you can then determine the height of the star. And when Brian Logic's faced with this necessary consequence of his line, he then says, I've seen him several times. He said, I can't remember now what he's like. It's really weird the way he gets out of that. He says it's not relevant or something like that. And he doesn't like going to the fact that you then, well, okay, Brian, tell us you've now worked out the height of this star. Tell us what it is. And he realizes that something's odd here, but he somehow, I don't know what. But they're just stupid.
And you've just come to that conclusion.
No, I've known. No, you see, the reason I'm saying this again is because people like Blue believe them to be the con men side, and Larry, I think, believes the same thing. Whereas I am more for they're stupid, and so so that's why I'm pushing this, because this is not. Although Blue obviously recognises that. Well, Blue doesn't think there's quite. I think Bev is really stupid. I think Blue thinks he's not quite as stupid as I think he is. So there's a difference of opinion here.
He knows exactly when to run. The minute you try to hold him in the corner, he just ducks and runs. He knows what's happening. He knows what's about to happen to him. That's why he's been so berserk over this reciprocal zenith thing. He realizes how damaging that is to every argument that he makes.
I don't think he understands what you've been showing him.
Oh, he does. I guarantee you he does.
I'll guarantee
he sees it. He sees it. He sees it crystal clear. He was absolutely panicked at the end of my presentation that day.
Yeah, I see. This is where we disagree. So this is Rob. This is why we've got a slight disagreement here between us. That's why I keep on saying
you can't tell. That's my
exactly.
contention. It's very difficult to tell. Unless you met these people and actually talk to them in person, you might get some handle on it. But over the internet is not easy, because
I don't know if you know, Rob. Yeah. I actually, when I was doing this, you may have heard I'm trying to do this Bedford Levels type observation at Welney, and I had the misfortune of being only 10 yards. Bev turned up with his acolytes on one occasion when I was there with Farmer's Boy and a couple of other people. And,
so you have met them, yeah.
Yeah, but I didn't want. I said I was in danger of, if I was to go over there, in danger of punching him, so I didn't want to get in this situation. And Blue actually warned me on the day this was going to happen. We thought it might happen because he warned us he was going to do it. And Blue said, "Don't go and get involved in a fight with him." And then, amusingly, about 3 weeks later, after Bev annoyed him, said, "Bloody hell, you should have punched him." So I did have possibly the opportunity of facing him and talking to him in real life, and in fact he did speak to one of my helpers, but I just didn't want to go over there and engage, because I do dislike the guy really quite a lot, and I could easily be driven to the point where I just, if he started using the same obfuscating, lying, misrepresentative tactics that he does on the internet, I would get very annoyed, and I just thought I'd just keep, as Blue originally suggested before Blue got really annoyed with him. I decided that just keep the distance, and I can't just avoid any possibility of me getting annoyed with him. And
by the way, Rampus, you can watch the video I posted.
Okay, I'll look at that in a bit then, Chikey. Thanks.
It's 17 seconds.
Anyway, so there's a difference of opinion, Rob, between me and Blue as to how much Bev is understanding.
Yeah, I'm personally more trending with Blue's point of view,
right,
or position.
I think I'm in the minority, actually. Yeah, I think a few people do agree with me, but there does seem to be quite a slightly larger contingent who agree with Blue. But I do find this, actually, that over the years, that the people who are not familiar with them tend to assume that they're lying and they're con men, and almost always it turns out, later on there's evidence that comes along that they really do believe this stuff and they really don't understand. I mean, things like some things like the QE and the Google Earth is a flat Earth model. I mean, you wouldn't say that sort of thing if you're a con man, and Bev is more stupid than QE. So,
Is that possible?
yeah, it is possible. I mean, QE does try, and he although I mean things like, I mean, he tries to investigate what entropy is. I don't think Bev's even and Bev didn't understand the black swan argument, and although QE for years misunderstood that, he thought the second law of thermodynamics and entropy were the same thing, and I had to keep on taunting him that he didn't understand. Now I think he's finally, because I've been hammering this point as of about 6 months ago, he stopped saying they were the same thing. So they do pick up on things eventually. If you hammer it home enough, I think you can make some difference to what they do. But as someone said last week, it's whack-a-mole. If they start to understand that they've been refuted in one department, they'll simply go and find something else to get wrong about, that they can pontificate about.
And you've got the reset problem, of course.
There is the reset problem, indeed. It's a very good point, that if you can convince a flatty in one debate, and they'll actually say they seem to understand what you said, then they wake up in the morning. I can't remember who coined the term, the flat Earth reset. Next morning, they wake up erased from their memory, because I think half the problem with the flatty, see, they've got several stages to go through when you're debating. They've got to listen to what you're saying. Then they've got to try and comprehend what you're saying. Then they've got to sort of put it in the deep brain. And then they've got to be able to remember what they've been told. And then the next day, they've got to be able to reproduce it. There's a sort of 5-stage series of things they've got to do in this: thinking, recording, and repeating. And only one of those has to go wrong, whether it's in the storage or the understanding. Then it then get wiped. So the whole experience gets wiped, as you say. And the next day, the flat Earth reset, they then repeat the same argument that you went through with them for about 2 hours. Then they even accepted it, that they were wrong. And then the next day, as you say, for one of those 5 they might even if they get to stage 3 where they've actually tried to store it in short-term memory, it doesn't mean to say it's going to get through to the next day. It's there's a whole series of intellectual problems they've got. And of course, in Bev's case, I think he's actually got some mental problem, because he forgets things that you I mean, something like the when I was asking about does he know that this down is towards the center of the Earth on the globe model, he didn't accept this. 20 times I asked him if he understood this, and 20 times he dodged the question. Now, this is where you might understand that this is the con man doing the dodging, but genuinely, I think he naturally dodges anything where he's pinned down to any statement. I think he realized if you're pinning him down, whether or not he just accepts, he just believes that if you're trying to pin him down, he's worked out that psychological part of it. If you're pinning him down to a position, he doesn't want to, like Oakley never wants to be pinned down to holding a particular position on something like having a model or something.
Yeah, well, none of them like it.
Exactly.
They all hate that.
Yeah, they hate
that.
They hate that. And so Bev immediately responds to anything like, Bev, do you believe, X? He'll say, well, I didn't understand what X meant, or what do you mean by X? I mean, that's the classic line from Bev. Is he'd say, if you say black is white, what do you mean by black? He always tries to disrupt the explanation so that he never gets pinned down. And now I've completely forgotten what the next point I was making.
But that is also a trait of a con man too.
Yeah,
it is.
Yes, I think he's a con man as well. Yes, I mean, he is. There's no doubt about it. He's a devious little misrepresentative, deceitful wanker. But he's also incredibly stupid at the same time. So the question is, how much is one or the other? And I think the stupidity is expansive and very deep. And it's just on top of that is the obnoxious, odious, malignant, malicious, deceiving wanker character sitting on top of this foundation of utter stupidity.
Well, just remember when he stood Homar, whatever that guy's name was, stood him down about the sextant. Sextant could only measure 60 degrees. You remember that?
Oh, God, yeah.
And he said it over and over and over again. And at the end of it, he talked about he said you could tell which ones of us were idiots if we thought sextant could measure more than 60 degrees. And I did a video on him, and immediately he went out and got himself a little wall hanger sextant. And all of a sudden, his sextant goes to 120. And you cannot get him to admit that he was absolutely 100% convinced that a sextant could not measure greater than 60 degrees because it's a sextant.
I don't know if you remember, Blue, but the next day after you did your video or what it was, I was also onto the case, and I actually had a debate with him in his thing, and I pointed out to him that he got this wrong. And no, that's right. He then dodged. He changed his position. He said, I didn't really say that, and he really was super devious, super deceitful. And I hammered it home about 20 times, saying, so, "Are you going to admit? Am I going to have to go and get the recording of you saying it could only measure 60 degrees?" And you, in fact, you PM'd me at the time, saying, "Yes, well done, Rumpus. Keep at it." And I kept at it, and I wasn't going to let him get away with because it was such an obvious thing. He tried to claim he hadn't said it. And there was an example of being a con man, deceitful wanker who just was not honest enough to admit that he'd made a really stupid mistake. So yeah, and as you say, he will not accept that he said this, even though we've got
to this day he's never admitted it. To this day, he will not admit it. You cannot pin him down and get him to admit that.
Was he ignoring the numbers on the arc of the sextant?
Presumably, or he doesn't. Well, he's never had one, of course. He's never touched one. And let's not forget, this guy does not believe that a theodolite has effectively got a plumb bob in it so that it can measure from zero. He only understands an autograph, and he just said it the other day. Was it 2 days ago in the review of your presentation? He actually said a theodolite does not have the equivalent of a plumb bob in it. The compensation. He doesn't believe it.
Yeah, some of them don't.
I mean, that's how much he doesn't know.
The modern ones, newer ones do. The old ones, like Larry's T2 or T3, it doesn't have a compensator in it.
But,
right, but it has something. But it has something that's equivalent of a plumb bob, doesn't it?
Yeah, it has a leveling vial attached to a vertical bar, so that's the fundamental equivalent of a plumb bob.
Right, exactly.
And of course, it's
not automatic like an auto level is, but the modern theodolites.
But he doesn't believe it.
Stick shift versus automatic transmission. Yeah, it's like
exactly.
You got to turn the knobs to adjust it. Believe me.
And he didn't. Yes, this was the thing a few days ago when he said that when I mentioned it to him in the chat, and he said theodolites. He does not accept that theodolites have got the equivalent of a plumb bob in them. So he doesn't even understand how this his devotion to the auto level. I mean, is limited to that. A theodolite is a whole new experience for him. That he seems to think that also because he's got one and that can generate horizontally. He doesn't believe a theodolite can do the same thing because he hasn't got one. He reveres the auto level.
Auto level has a plumb bob in it.
Yeah.
But he didn't know that. I mean, we were having that debate with him. He didn't understand that. He's disputing that as well.
Wait, why would he even express an opinion of something he's not familiar with? There's nothing about it.
That's never stopped any flurf yet.
No, sure.
So my point is about the
they do not see sheer ignorance as a stumbling block at all. No. They just don't.
This is what Dunning-Kruger does for you. So the fact that he didn't know what a sextant did because he didn't have one is not a surprise given the fact he's got an auto level and still doesn't understand how it works, and he still doesn't understand where it gets its horizontal from. He does not understand that it's all based on vertical and the gravity direction. Stupid wanker. See this? So you see, if he was a con man, he would not be saying this sorts of thing.
But what would he say to make his position? That's the thing.
Well, he would come up with something else. He would say, "Yes, I understand that it's got effectively got a plumb bob in it, and it's got this compensator thing, which I could have looked up on the internet as to how it works." So if you're a con man, you wouldn't offer arguments about there being no plumb bob in a theodolite or no plumb bob in an auto level. You wouldn't say that if you were a clever con man. So this is why I put him definitely firmly in the. Is fundamentally this problem is his stupidity. A line, and then the malicious, lying, wanker, deceitful bit of it is just an ice cream top. It's a topping on this stupidity.
The problem is once they admit in gravity, then it's over.
Yeah.
Well, he doesn't. It's odd that Bev doesn't really talk about gravity at all. The other flatties dispute that it exists, but Bev, he just seems to just ignore the whole issue.
But along with what I'm saying about gravity, I also am meaning the vector of, pointing down to the center of the Earth. And so in any sense, if they omit that they're doomed. That's it. Their argument is gone.
Well, certainly Bev has said, as I say, I quizzed him 20 times. Did he understand that down was towards the center of the Earth on the globe model? 20 times he ignored this. But the next day, He did say he understood that was on the globe, but again, this is. As
I bet it's reset by now.
Yeah, the trouble is, but I think in Bev's case, he has got some sort of mental deficiency in memory. He seems to forget things that happened to him the previous day, which are not controversial, which you'd have thought you'd just remember. And I think he's got some genuine problem. But that's my opinion. Well, he's got lots of problems.
I was going to say Rumpus.
but his memory seems to be one of them as well. And converting to miles is another problem, and just doing any maths whatsoever, which like any other Witsit or QE. I mean, QE can't. Oh Jesus Christ, QE and that negative that Blue did a video on, that and minus 17 Tor and. Trying to get what was it? Oh Jesus Christ! What was it? It was the minus 17 Tor thing, but there's that one where minus 1. Was that part of the minus 17 Tor? Oh, I don't know what. You did another video on that. There was 2 videos. I thought one on the misunderstanding he couldn't subtract 2 numbers from one another. Was that PSI? Yeah, I think it might be PSI 17 10 to the minus 17 Tor. He thought it was negative. Of course, I think.
Yeah, that's right. They assume because it's minus some number that is a negative number. They can't get their head around the fact that it is actually a very small positive number.
Yeah,
and that's a big thing. At no time is that a negative number. It's always a positive number, no matter how many numbers you put there. It's still positive. It just gets smaller and smaller.
Yeah, I mean the reveration they have for that number there, you can see flat and say, and in that space is 10 to the minus 17 Tor. How empty and how vacuumy can it be? My God, it's 10 to the minus 17. Excuse me, but 0 small that. But no, 10 to the minus 17 is just really vacuumy. Oh.
Your head's hurting, Rumpus.
It's just the stupidity. So I think it's mostly stupid. If you align a lot of stupidity, as I say, and you don't understand what contradiction is, you don't have to deal with evidence because you don't have to accept contradictions because you don't understand them. Then you can just let your imagination run wild, and stupidity plus a delusion, and you're away, and you can't be refuted because the only weapons we've got are logic and evidence and reason. And as I say, they've got this what they call the shield of stupidity. If you can't use those weapons of logic, reason, and evidence, then they're invulnerable. You can't beat them around the head with anything because they have no. They don't see the contradictions. They don't see the problems, and you can't get into their head and say, "Look, there's this huge problem you've got here." No, they've got this portcullis thing. Just no, they're not coming in. Logic not here. They're just stuffed. So it's very difficult to get to. The more stupid they are, and that's why also I believe they try and keep themselves stupid. You can tell that they don't want to learn about something for fear of it upsetting their model they've got in their head of the way things work. And so they actually, by keeping themselves ignorant, they can then justify justify rejecting by something. I didn't understand that, and they know that if they learned about things a bit more, they'd understand a bit more, and they'd be in danger of being convinced by you. So they keep them. I think unconscious. I'm not sure this is conscious or unconscious, but certainly they seem to have a motive to keep themselves ignorant and stupid because it then strengthens their shield of stupidity. That's my theory.
I think sometimes their world would fall apart, if they were to think too much about.
Yes, I think if they were to think hard and really try and learn, because that's why I think because they know that if they keep that willful ignorance, that they can then stand by their current arguments. Whereas you don't want to be invalidated. And if you start learning about things, there's a danger that you might
that you'll find you're wrong.
Yeah,
somewhere. Because
some of these people are devoted to it.
Yeah. I've always said, anyone who's not wrong has never done anything.
Yes. Though I've been through that phase now.
Yeah, we're all wrong about something. We all make mistakes,
Yeah. Oh, it's Lewis.
Oh, it's not the same Lewis, though.
Oh, it's a different Lewis. Oh, all right, okay.
I'm sorry to disappoint.
That's okay. I'm sure Blue be very welcoming to any new person.
Yeah.
Do you
I
know
saw
the
there was a
Flew?
live.
Hmm.
Sorry?
I just wonder if Flew knew you. Are you new here?
Not quite.
No.
Actually, I was absent for a few days, a few weeks, but I was quite present in the last
Right.
shows and in Jose's show as well.
Oh right, I haven't been back to Jose's for some time. I just got fed up with well, I mean, he just used to disrupt my presentations and things. I just got annoyed. And one very special was about 2 years ago. He disrupted one of George's and introduced, in fact, and brought in oh God, who's that guy? The one guy, and then yeah, he completely sabotaged one of George's presentations because he thought it was boring, and I decided that. And he says he doesn't want to be educational; he just wants to be entertaining, and I don't think he's very entertaining either. So anyway, so I don't tend to get on Jose's anymore.
Yeah, it's a very different kind of show. It's one that I enjoy sometimes, and sometimes it's very infuriating. I also voiced my the fact that I really didn't appreciate the way it was handled sometimes. Like we could really have long conversations with flat earthers who would keep repeating the same things over and over and over again for like tens of minutes. It's just like monkeys throwing shits at everybody around them. And it's not even entertaining. It's not pleasant to be there. It's not pleasant to listen to it. I just lost interest at some point.
And of course, Jose doesn't believe we've been to the moon as well, and he's getting very distressed. And when he was saying that the launch was being put back year by year, he thought this was some a lying, deceitful action by NASA. The fact they delayed the Artemis mission to the moon, sending people to the moon, the fact they delayed it by a year or whatever. Oh my God, they're deceiving, lying gits because they did this instead of thinking there's an economic reason for it or whatever. He seems to go off on some strange, you know.
Or some really technical reason, like the rocket might explode if we don't fix this problem.
Yeah, they bloody whatever those pipes are that keep on bloody going. They're still not fixed properly, are they? They're still having problems with them. I mean, honestly, get a plumber in there, mate.
It's really easy when you've got fuel at minus, a couple of 100 or 270 degrees, 250 degrees. It's really difficult to keep your pipes from coming apart.
Time. They did it last time. They sent 3 plumbers there.
Yeah, just get some plumbers in. Really thought. I mean, okay, it is. I mean, what is it? Which one's it? Is it? I can't remember. What's the fuel in the Artemis? It's liquid oxygen. Is it hydrogen? Liquid hydrogen?
Yeah.
Yeah, right. Yeah. So that's minus. What's that?
Liquid hydrogen is very cold. Minus 400 and something.
Well, okay, we were in centigrades in central. Minus 250 degrees C or so.
Okay. All
right. Just about 50K or something.
Well, yeah. People who have actually sent shit to the moon,
about 30, I think.
like guys, we use Fahrenheit. Sorry.
Yes, handicapped by that. Yeah, well, don't forget the Russians did everything in space except get men to the moon first, and I actually wonder what the Russians use. I presume they use Celsius.
No, they're metric. Yeah,
they're metric. Yeah, they got it from French.
It's easier to say who isn't metric.
And of course, NASA these days is metric. They've learnt their lesson. In fact, you're not allowed to write code. You're not allowed to write code anymore for any NASA mission that's not metric.
No, they still rate their engines by pounds.
That's the only thing I think. But not. I think they. That might be what they put up for publicly, but they do all the science and all the internal stuff metrically. Yeah, exactly. I bet they're using.
The interesting thing is they went to the moon in the 60s, changed to metric in the 70s, and haven't been to the moon yet since.
But they've been to Mars though since then.
Yes, they have.
So I think, although of course one of the missions famously went wrong because they got the metrics and imperial measurements having a conversion problem, and that was when NASA finally said, "That's it, no more code." In imperial units or British units, whatever you call it, in English units, whatever you call it in America. They gave up. That was the thing that did it. One of the Mars missions that went wrong due to a conversion issue. They just at that point NASA said that's it, no more code only in metric.
Wasn't it because it was a collaboration that actually it's the other company that was feeding the data, which were in imperial?
Yeah, it was. I think it. Yes, it wasn't just that. Yes, I think it was actually some. Yeah, it was a conversion between.
It's a European space collaboration between NASA and European Space Agency from memory.
I can't remember.
Yeah. So the different contractors, they had their own workflow, and so there was a meeting in the middle, and where there had to be these conversions. Well, in a proper ISO scenario, they would dictate, at the ground level, you have to use approved softwares, and those softwares will not have conversions. They will have this value for this unit.
Yeah, now that's what they insist on. That. Yeah, I think it was a contractor issue, but now they insist that any contractor they use also has to use metric units.
Well, in ISO world, there would be ISO certified softwares and ISO certified processors.
Yeah. So so they learnt their lesson on that Mars mission, and then now it's metric only. Okay, so they might for the American networks or whatever, they might present everything in pounds of force, but I bet internally this all worked in kilonewtons, as you say. Whoever it was Rob said.
And what I find charming, so I've been looking at 1900 report from the year 1900, where they transcontinental triangulation across the entire continent of North America. It's 100% metric. Thank you very much.
Yay.
Oh, and interestingly enough, Larry, I don't know if you know this. I'm sure you probably do, but those two angles that on that graphic that I put up of yours, if you work out where they intersect, it's about 7,400 kilometers below the picture, which oddly enough is the refracted diameter of the Earth.
Right. Yeah.
Yeah. I was looking through that report. There's hundreds of reciprocals, and to pull out the mammoth ones, the ones where both angles exceed 90. It only do so much. So again, I have that one that's 182 miles, and I was gleaning through to see it's in fact the longest.
Yeah, I was just sitting here doing some rough, just for fun, using those two angles, sort of, and seeing what where those what the length of either one of those lines would be, and that's what it comes up to. It's about 7,400 kilometers from each theodolite to the intersection of the triangle it forms. Amazing.
And surprise!
Now, for fun, multiply it times 6/7.
That's what I did. Yeah, and you come up with with the radius of the Earth.
Yeah, well, they always say 7/6R. Well, okay.
Yep.
Yeah, you got your 70-some hundred kilometers, 6/7.
Yep. Absolutely.
Yeah, like in my valley survey, I got 7.11/6.
Funny how this always works.
Yeah.
Absolutely. Yeah, it's nice, isn't it, when you get lots of independent means of measuring something, it all comes up with the same answer.
But the FLIRF still say it's flat. You shake your head.
And their issue is going to be authorship. Oh, the U.S. Coast and Geodetic Survey. Like they would tell us the whole truth.
How are they going to react when we get photos back from men standing on the moon in the next couple of years?
Fake.
CGI.
Yeah. Fake. Done on soundstage. Stanley Kubrick rose out of the grave and did it.
Stanley's back. Yeah.
Actually, it's worse now than it was before. At least before they were using film cameras. Now they're using digital cameras, which technically all digital photos are composites. And a composite photo is a fake.
That means that every picture you take with your cell phone is fake too, then.
Yep.
It is. It's a composite because it's compositing the red layer to the green blue layer.
I know. I saw this. There's this one presentation that basically says that all pictures are basically spreadsheets.
Did you hear about this theory they have that telescopes have got digital images in them, and they actually add in stuff into it? I mean, Jesus Christ! I mean, the levels again. They think of things that you would never, ever, ever dream of, because when you have no constraints on what you think can be done in the real world, you can just make up anything. And George and I was always telling George, I was always stunned every week or so. They come up with some new way that something could happen that you just. Even your wildest, freest, most surreal imagination would not think up, and they come out with it. It's just amazing.
And that's why I don't think they believe themselves. They're just saying that for the comedy aspect, or to, again, the game of, can you top this? It doesn't matter what you say, they'll say something more bizarre.
No, Larry, it's just that they do not have any constraints on imagination. Whereas you start thinking of something that's a bit weird, you say, oh, that can't work because of geometry or physics or chemistry or logic. They don't have any of those constraints. They don't have any of those hurdles to get over to. Their memory just runs rampant with their wishful thinking. Their brain just goes on rampant mode. It's just there's no reining it in by anything. Whereas we were reined in by logic and reason and evidence and science and everything. No such constraints for them.
I don't even know where they get buzzed. I mean, it's not even connected to the tube. It's only the computer is connected to the drive to take the computer to where you tell it to point, and all it does is point them to the telescope.
And telescopes don't have to have that.
I know telescopes don't have to have that. Is another point, but.
Again, not an issue for them. It's just extraordinary. This is why I think they're just stupid.
Yep, old telescopes. It was just done with gears and weights.
Well, and they start motorizing them to.
Yeah,
Yeah, we've just just finished putting a very old telescope built in 1864 that was damaged in the Christchurch earthquake. We've just finished putting it all back together, and there is no electronics, there is no nothing, just a weight to drive the mechanical clock that tracks the telescope.
What do you do?
And Herschel,
how does it move the telescope?
Sorry, what's that?
Herschel had his sister to drive it.
What do you do, Rob? You've been putting telescopes back together. You were
an old telescope. It was badly damaged in the Christchurch earthquakes. Is
that what you do for a living?
No, I work for a physics department. I'm a technician that builds stuff. I mostly work with ring lasers, actually, but I've been seconded to help put this telescope together. I didn't do the restoration.
Which earthquake was this?
It was in the February earthquake.
Oh, okay. So is
about 10 years ago. Yeah,
I'd say it was a while ago, wasn't it?
Yeah, it was 11 years ago, but it's taken us this long to get the telescope restored. It was incredibly damaged. All the tubes were crushed. It was massive. But what was the amazing thing is that the lens survived. It's a 6.6-inch refractor. It's built by the Cook brothers in Scotland, I think, in 1856. I think the nameplate is.
So
built in 1850.
Is there anything that moves the telescope to?
Yes, it's got a mechanical weight and a clock and a mechanical clock drive.
Okay, that works.
So it uses gravity on a big lead weight to drive the clock.
Oh, yeah,
and that moves. Yeah, and then it's a Altair mount.
Oh, gravity's fake too, so.
Yeah, yeah. This telescope works. We haven't looked at a star yet. We've only finished it yesterday, putting it together.
It's a refractor, a 6-inch refractor.
It's a 6-inch refractor. Yep.
Wow.
Yeah.
Is it pendulum or spring?
Sorry.
The clock.
It's a straight weight. It's a straight weight.
Pulls
down.
The clock.
What's the escape? Yeah, what's the escape mechanism?
It has a mechanical governor in this clock.
So it's
doesn't TikTok.
No, it doesn't.
It's one of the ones that have a centrifugal.
Yes, it is. It's a centrifugal governor in it. Yes, exactly.
Okay.
Yep. Yeah, that was all crushed, and because the whole tower, it was all stone tower, and it all collapsed and crushed all this. And one of the guys rebuilt it. I wasn't involved in the rebuilding of this. All I helped was the assembly of it. It was lovely. It's really nice to see it back, and they've rebuilt the tower, and
Did
with the aid of some.
They put rebar in it this time?
Yes. It's a concrete reinforced tower that they built this concrete cylinder, and they split all the old basalt stone, and they cut it and basically epoxied it and reinforced it to the concrete column.
Okay.
It looks exquisite. The stonework is just beautiful. And that's partly why it's taken 10 years to rebuild. It's, a massive job.
Yeah, building stuff to earthquake code is a lot tougher than just putting a bunch of bricks together.
Yeah, well, that's basically what it was. It was 2 layers of brick and a layer of rubble.
Yeah, it doesn't
and that's
work
how it was built in 1900, whenever the tower was originally built.
So it doesn't work too good in earthquakes.
No. As we found out, all those old buildings all fell to pieces.
Normally, it's the old buildings that survive because, of course, they've survived for a reason from previous earthquakes. And I think it was in Mexico, for instance, it was all the old buildings that were fine, and it was all the new ones that fell over because all the old ones had been sufficiently strong enough, or by a process of evolution or selection, the only ones that had been left standing are the ones that could stand up to these sorts of things.
Yeah, there's a flaw in your argument there, though, Rumpus, is that if your earthquake cycle is longer than the buildings existed, you see, and that was the case here in Christchurch. We're not an old city. We were built in 1860, and of course there's long periods on the earthquake cycle. So, but that you're quite right. In cities that have been there for a couple of thousand years, providing your earthquake period is great, is shorter than the life of the building. Of course, that all is valid.
Yeah.
And this is what they'll find out in the central US. How good their building code is.
That's gonna be horrible when that one happens. It's that they're not ready for that. No, not San Francisco. We're talking about New Madrid.
Yep.
New where?
New Madrid. It's in Missouri. It's the worst earthquake in the United States. It happened in 1811. From Missouri, it rang bells in New York and Boston. The Mississippi River ran backwards for 2 days.
Oh wow!
Yeah, it was a really powerful earthquake. They think what's happening is that the North American Rift Valley is opening.
Oh God! Right.
But it's going to be really nasty. Places like we were talking about this earlier. Places like what was it? Memphis is like right on top of the earthquake. It's gonna be bad. San Francisco, at least they build for it because they know about it, but people have forgotten about New Madrid.
Right, I see. Okay.
Are they developing the code in the area to, now with modern, knowledge of that fault? Are they upping the building code?
But it's out of sight, out of mind. Why build for something that only happens once every 2 centuries? Because it's 2 centuries now since the New Madrid earthquake, and there's no indication it's going to happen again. So they have no idea how long this cycle is.
Yeah, well, the earthquake here in Christchurch was actually on a fault line that we didn't know existed.
Yeah, they do that in California too. They built a nuclear power plant over a fault they didn't know existed.
Yeah, of course, you can only know a fault's there by it moving, or getting seismic data from the fault. If you don't get any data from it, and then suddenly it moves, you go, "Oh, okay, that's new."
The other bad one is going to be the Legend of the Thunderbird, which is the northwest United States, up by Seattle. There've been historical tsunamis that have 100 feet, not hundreds of meters, but 30 meters high, and that appears to happen, and that hasn't happened for a long time.
I think there were 100-meter tsunami in Alaska.
Somewhere.
Valley.
Yeah, when the mountain dropped off. Yeah.
Yes, that's it. Yeah, that's the one. A bit of mountain dropped off. Yeah.
Yeah, they couldn't figure out.
I was up there. Go ahead. I'm sorry.
Yeah, they couldn't figure out that there was this valley with a really weird tree line. They said,
Yes.
"Wow, that's like 100 meters up. That means no, that can't be a 100-meter wave. No way. That something else
Yeah.
must have happened." Yeah,
Yeah.
and then apparently there were a couple boats in that
That's
bay
right.
when
Yeah.
it happened. One of them got swept over the headlands
Yeah.
and survived.
That's right.
There's a restaurant on a bluff in Kodiak, Alaska. It's about 200 feet above the bay. They got wiped out. They have pictures before and after, or paintings and stuff before and after. It's pretty amazing to stand up on that bluff next to that restaurant and see how high the wave was that took that restaurant out.
Yeah, they actually learned a lot about cavitation, and they actually had to model it. They actually have models built now. They take a bunch of gravel and drop it into a tub basically and measure the waves.
Well, of course, the big example here is at Gran Canaria. There's half the island. It's not on Gran Canaria. It's in the Canary Islands. There's an island, Huja Vita or something. I can't remember, some Spanish type sounding thing. Where half the island or a third of the island, or perhaps a quarter of the island, is going to slip off, and it's going to send a wave all across the Atlantic and flood New York. Which is what they're all waiting for.
That was going to wipe out the East Coast of the United States. Yeah, it's going to be bad.
Mm.
Apparently, it slid like 6 inches and stopped about a decade or two ago.
Yeah.
Yeah, that's not going to be good either.
Yes, it's amazing how this water is so good at transmitting this sort of thing at that distance. It's extraordinary to think that just a collapsing rock over there causes a 100-meter wave over there,
Or
2, 3, 5,000 miles away.
Or a thrust fault in the middle of the Pacific raises the ocean up 30 feet and then suddenly disappears, and then like 6 hours later, cities in Japan get wiped out.
Well, the Japanese have a tsunami, recorded tsunami, 17. Can't remember offhand this certain date, but its origin was the United States. It was this fault off Washington State.
Right. That's the same one. Thunderbird.
Yeah, and they have it's recorded in the Japanese history, but not, of course, it was pre-European settlement of that part of the United States.
And they found remnants of it, and then the Japanese will have a lot more warning than the United States will if that happens again.
Yeah, absolutely. Yes, they'll get plenty of warning. The US will get almost none. Well, they'll get some, but
not enough to matter. Enough to bend over, kiss your ass goodbye, but that's
Yeah, we don't get. Well, actually, I was about to say we don't get earthquakes in this country at all. We're all very civilized over here. But in fact, actually, about 10 years ago, we did have a slight wobble. No, sorry, that was it. It was a year ago. There was this there's a great thumping sound or something in the house. I couldn't know what the hell was going on, and I dashed out the front to see what had happened. Whether something brutal had come off, and then suddenly I realised everybody else had come outside their house as well, and we were all staring at her, thinking, "What's going on?" And we'd had a little tremor, which was very outrageous for this country. A tiny little tremor that got everybody excited, and that's all we ever have around here. We're all very civilised and well behaved here. The weather and everything.
Yeah, and soccer hooligans and all sorts of.
Well, guys, I'm gonna shut the YouTube stream down at this point. I think we've had plenty of fun this afternoon. Wish Bebby was still here. I want to say thanks to him again, though, for his presentation.
Yes.
And if you didn't see that, go back and watch it. And like my video while you're at it, okay? So with that, YouTube land, we'll see you guys on the next one.